Yeah, so let's get started. We will have a quick revision and then I'll go through. I don't know whether you have really revised about IO yesterday, at least one batch which was with me. I'm not sure how much they have revised. So we'll have a quick revision. I'll take you to binary data streams and we'll cover the important data stream, which is your object streams. Object input stream, object output stream. And then rest of the day we are going to spend in threads. So let us get started. Uh, when we talk about Java input output, which is the package, there are two packages which are supported, which is a package we are currently looking at is java.io. And then there is a new IO. So there is a java.new. And then there is a java.new.file channel. There are a lot of sub packages. So we are talking about mainly here java.io. So when you say java.io, the APIs, the methods, basically IO is input and output, read and write. So these methods, if you talk about read and write methods, are these the blocking methods or non-blocking methods? B or NB? They are blocking methods. You will, today we are entering threads, so you'll know the blocked state and the ready to run state and all that. So these are the blocking APIs. What it means is anytime you are performing a read operation or write operation, unless and until read or write operation is complete, it will cause the blocking of the invoker thread. Meaning, whatever is the thread, whichever is executing this read and write API, will be blocked on input or blocked on output. And such, if any thread, you'll see, if okay, forget threads because we're not yet formally entered threads. But if any part of the code is blocked on input or output, if you are using Java IO APIs, you cannot send something like an interrupt signal to unblock. If you ever do the Java Neo in T or in proper depth, you will see that this is non-blocking IO, meaning there is a possibility, there is a mechanism to send the interrupt signal and unblock the blocked threads. So that is just a little bit of difference between Java.io versus Neo. When you talk about Java.io, I'm not talking about Java Neo because it is a different infrastructure altogether, consisting of channels, buffers, and all that. So I'm talking about Java.io. So mainly consists of streams. Okay. So when you talk about streams, streams is nothing but the data transfer medium. And mainly, if you talk about raw streams, they are the data which flows through the streams is, it is binary data streams. Of course, you have formatted streams, but typically the streams consist of, stream represents a data transfer medium and nothing but byte oriented. So you have taken a look at yesterday, there are so many devices, console, standard input, standard output. You have file handling streams. If you have two threads and you want to actually transfer the data, you have pipes. If you write a networking application, distributed application, you have the endpoint of communication in form of a socket. So as I said earlier, stream just represents a data transfer. These IO streams have nothing, yes, nothing to do with your what? With your Java 8 functional streams, which we talk about. Java.util.stream is the package and the name of the interface is stream. Then you have seen in stream, double stream, etc. They don't have anything in common. These are for handling IO devices. The other one, Java 8 streams, is based on functional programming pattern. So don't mix them up. So now if you want to read the data from any of this data source, be it system.in, be it file, be it pipe, be it socket, into the Java application, what type of a stream would you like to open? Is it input type of a stream or output type of a stream? Here, pretty easy question. To read the data from the data source into Java application, of course, you'll require input type of a stream. And when you have certain data which you want to send it to some data sync, what you'll require is output type of a stream. Everyone understands that. Now, you have seen three different categories of the streams depending on the functionality. So which are the mandatory ones? Mandatory ones are node streams. Always think in example before going further. So yesterday we were talking about files. We have not yet entered the binary files which we will enter. So you remember file reader. Okay. You have a file writer. I'm just writing a couple of examples. Yes. Then if you change the device from file to pipe, there is a corresponding pipe reader, pipe writer. You have socket related streams and etc. So when you say node streams, are these mandatory or are these optional? Yes, node buffer and filtering. These are mandatory. Without using these streams, you cannot write any Java code using java.io API. Java Neo is totally different, I told you. But if you want to learn java.io, use this. You have to use these stream classes. So these are the ones. What is the job of it? Node streams are buffered or unbuffered. Answer is they are unbuffered. Means what? Are they going to provide your buffering or store the data in an intermediate manner? Answer is no. So the job is device handling, the abstraction. They will manage the handling of the device for a Java programmer so that you can write, here I go, so that you can write the code in a platform independent manner. So that is your node streams. Next one, already somebody has suggested, buffering type of streams. So what is it? Obviously, the job of it. They are optional, but recommended for large data transfer. And when you talk about it, think in examples. Can you give me any example which you have seen yesterday? We have seen certain example. At least two you should be able to quote. Buffering streams. Anyone? So if you remember, we are still in character data. So buffered reader, and you have seen buffered writer. But in addition to that, you have also seen the better one, better equivalent of it is a print writer. So what they do is they introduce a buffer. You can introduce a buffer using these stream classes between your Java application and your device. So Java application doesn't have to directly read the data from the node stream in an unbuffered manner. The data can be deposited or dumped into the intermediate buffer, and Java application can can read or write the data from the buffer very easily in a higher performant manner. So these were the ones. And the ones which you'll be using today are called as filtering streams. Filtering are also called as conversion streams. And these are the ones which will convert, I mean, not only bytes. Okay, so I'll just say it will convert the bytes into, it can read the bytes and convert it into Java primitive types. Okay, so the name of the stream classes is data input stream, data output stream, pure raw binary. You can have the streams which convert bytes into a character. There's something called as input stream reader. It will read 2 bytes, convert it into a character. Or the ones which are really mentioned in your contents, and that's truly important, is you can have the bytes, and those can be, I mean, you can use the binary data to reconstruct Java object. And you will see this is nothing but your deserialization. So all these things and much more we will be looking at today. If you say no to using these conversion streams, who will have to do the management? Who will have to manage this conversion? Answer is programmer. And when you have ready-made support, we will not waste our time and energy in doing these basic conversions. Okay. So now tell me. Now let us talk about the hierarchy. So if you open java.io, can you tell me what are those 4 abstract superclasses at the top? In java.io, there are 4 abstract superclasses at the top. Which ones? Because at least that much you have to remember. So input stream, output stream, reader and writer. Very right. So they are input stream. These are the top level this classes. output stream. I'm taking a little more detailed revision than always because I don't know how many of you have really done this. So, and a reader and a writer. Okay. So they represent four hierarchies. So tell me, we did that and it is pretty easy. I'm telling you, I'm not bluffing. But IO is seriously easy. Coming back. So here, input stream, when you say, what does it represent? Binary, as in byte-oriented input stream. So which type of methods you expect to see? Byte-oriented or character, and read or write. You know, you have two answers to give me. Which methods you expect to see when you open the class input stream? Of course, byte-oriented and read. How about the next one? Easy questions. Of course, we are still into binary. But all you will find is yesterday I showed you write methods. And when we talk about reader, what is it you expect to see? Character and read. And the last one is character and write. Okay, that easy. But these are kept as abstract because they do not represent a specific behavior. So from these, there will be the classes, concrete subclasses, uh, extending from these hierarchies. So from input stream, you've got, I'll not write, it takes a lot of time. File input stream, piped input stream, socket input stream. I mean, there's no socket input stream, but socket.get input stream. Then you have buffered input stream, data input stream, etc. Then you have similarly your file output stream, piped output stream, etc. Piped reader, file writer, pipe writer, etc. Okay, so all these represent the four hierarchies. And once you understand this much, all you have to like come down these individual hierarchies and explain, I mean, solve the objective. So here it is a revision. So here I'll give you inputs. We are not going to write it. We'll just write so much, only that much, which will, make you like reconnect with what we said yesterday. So what is it? The first objective, simplest objective we solved was reading the data from the text file in a buffered manner. And I don't want to do it in a imperative style where I have to write the loops and while conditions and all that. I want to do it in a declarative manner. So these are the inputs. So I'll ask you a question, please respond. So what is the, I hope you remember, we talked about chain of IO streams. So I will write two ends, you fill in the blanks. One end is Java application and the other end is your device, which is what? Text file. Okay. So are we reading the data or are we writing the data? We are reading the data. So can you tell me? I hope people are already writing the chain. Okay, we are reading the data. Fine. So can you tell me what is the node stream I should place here? We should place here. We have done this. Not really. Immediately buffer reader is wrong answer. Buffer reader cannot handle the devices. File reader is a correct answer. So how we are doing it? It is which device you are reading? Text file. Are you reading or writing? Reading. Is it character or binary? Character. So that narrows your option to file reader. So this is your file reader. Technically speaking, legally means compiler wise, can I directly, exactly. So this is your node. This is your totally node, which you cannot decouple. Okay, coming back. But if I place my, probe here, what kind of a data it is, unbuffered or buffered? Of course, it is unbuffered. So it is fine. If you connect it directly to the Java application, there are read methods, character oriented. But if you are doing a larger file, I mean, size is this, you need to get a buffer in between. So which is the name of the buffer you have? I mean, which is the name of the class? Buffered reader. And as somebody said, buffered reader is not partial to only file data. It is partial to character data. So what does a file reader say? File reader can only read data from the text file, but buffer reader can store character data from any device, which could be what? Socket, file, pipe, memory, anything. As long as you are giving it character data, it's good. And then you can connect this to your Java application. So without drawing the chain, I think this is clear. But this is only for understanding. So tell me the next thing. Are all these Java IO classes auto-closable or not auto-closable? They are auto-closable. Everyone knows that. So can I open it with try with resources? 100% yes. So start. I'm not writing scanner. Imagine scanner is already created. I mean, you can create scanner in any time, middle of night or whatever. So start. I will write the left hand side. Buffer reader BR is equal to, give me the next one. So now you have to literally go and trace the chain till the device. So here you are creating the instance of the buffer reader. Buffer reader is wrapping which device? Sorry, which stream? A node stream. New file reader, and one of the constructor argument of the file reader is file name. So you can say sc.next or you can say sc.nextLine. Depends on this. So here, this is your try with resources. And if you get any exception, sorry. So if you get any exceptions, of course, is this going to have any checked exception? 100% yes. If you try to open the file reader and file doesn't exist, which is the exception you have, is the file not found. So here is our ordinary catch-all block. I have not yet separated. We have not yet separated the tester or collection or IO in separate classes, separate layers. So this is it. This is a simple design. Next one. So start. So what is it we are saying here is, now I have to keep reading the data from the text file till end of file condition in a buffered manner. So there are two approaches. One is br.readline. It returns you null at the end of stream condition. Either you use that or scrap that and use the stream approach. So which is the method you have seen? Yeah, exactly, Arjun. But I'm saying I don't want to do that. That's just such a traditional approach. So you have other approach. I hope you remember. Just a second. So here, because I'm serious, I'm not sure how much of a revision you have done yesterday, knowing the exam and all. So buffer reader, and you can look for a lines method. Okay. So here it is returning a stream. Which stream? Java IO stream or functional stream? Functional stream, right? The java.util.stream is the package name and name of the interface itself is stream. So this is returning your stream, which are the lines of the data read from buffer reader. And once I take you to stream, I hope further things are easy. So br.lines. Now, I just wanted to display it. So it becomes so easy. So here, what is it I have to do? This gives me a stream. So which are the important interfaces, important methods? One of the terminal operation is for each. So can I attach a for each here? Of course, yes. And if you ask me, what is it we are going to do in a for each? I'm simply going to call exactly existing method. So I can even, yeah, both Nikhil, your answer and Vipin's answer, both is correct. I can even further reduce the lambda expression by a method reference. So which method you want to call? You are passing that method as via reference. Okay. But if you just write println, you'll get a compiler error. So you will have to tell the compiler whose method it is. So it is on the object of system.out. So you can check the code becomes so readable and so easy to write. Is everyone 100% clear so far? Okay, 100% I don't know, but somewhat clear. Okay, great. So then we had proceeded to writing the data. This just covered the reading part. So when I say copy text file, first half is the same. So let me just copy this. So here, copy the text files in the buffered manner. So this is your chain of IO stream, as in for reading. Now give me the opposite chain. So Java app wants to write the data to the device. So tell me, do we want it in a buffered manner or the unbuffered manner? Answer is buffered. But like somebody suggested, if you choose buffered writer, please read those diagram slides and all. Buffered writer has got only couple of write methods. So if you want to enjoy the, powerful APIs such as print, println, printf, and write methods and all that, which is the equivalent of it is print writer. So let me ask you, if I ask you the question, where will you place this print writer? Means under which hierarchy? Numbers, take numbers 1, 2, 3, 4. Where will you place the print writer? Of course, under the writer. See, it is so easy. It ends into a writer, makes it character output stream. That easy IO is. Coming back to the point. So print writer, and print writer has a buffer. So tell me, I'll cover that also. Can you tell me which are the triggers? Okay, I'll write it separately in different line. Which are the triggers for the data from the buffer of a print writer to reach the next node? So one trigger is obvious when the buffer is full. Okay. Or are there any other triggers? You know answer. If you call flush, there is a method you can check the API flush. So even if print writer buffer is 10% full, 50% full, and if you say pw.flush, you are forcing the data. You are flushing out the data, sending the data to the next node. So flush. Or if you have auto closable close and all that, this is also a trigger. But these triggers were also present with buffered writer. So here print writer adds one more trigger, and that is called as automatic flushing. I don't like to call it as automatic flushing because it doesn't tell you anything. So what is that? When will print writer's buffer get automatically flushed? Of course, there is a constructor for enabling that. So it is actually flush on new line. I'll show you so that you know. I'm not saying you might require it today, but anytime you require, you should get it. So simply search for print writer, and here you can see they have given, see, if automatic flushing is enabled, it will be only done when the println, printf, I mean, whenever you send the new line character. I'll show you. If you look at the constructors, there are so many constructors. It is a much more powerful. You'll see in our servlet programming, J2E programming, we will be using, or the API uses print writer. So that is my real intention. So coming back to the point here, see this. Take a look at it. What is the first argument? The writer. So can I replace it by file writer? Yes, file writer is a writer. Can I send, if I want to send the data from the buffer to a pipe, what will be this replaced by? Pipe writer. If I want to send this data, little bit tricky, to the socket, can I connect it using this? Answer is no. But why I'm saying, okay, why I'm saying it is not possible? I said the writing the data to the socket using this constructor is impossible. Why? I said something yesterday, but I don't know how much it is. It is because socket doesn't directly understand. Okay, I'll make a proper statement. Only binary streams can be attached to the socket device. In short, will socket allow you binary streams or character? Answer is binary. But here comes the beauty of your what? Print writer. Wait a second. See this. Print writer can also wrap or can also take or rather send the data to output stream. So this is little confusing. I mean, I'm not saying you might require it, but I'm just, since I'm on the topic, might as well. So what it does is, when you hear in the middle of night print writer, it is a character output stream. But now see this, creates a new print writer and all. And what it does is, when you say output stream, can I write it to a socket now? Answer is yes, socket output stream. Binary streams can be attached to the socket. But what this fellow will do is print writer. Why I suggest print writer, one of the reason, it will do the conversion. Read it. Everything is given in Java docs. So it will take a character. The data in the buffer will be still character. How many bytes is character in Java? UTF-16, 2 bytes. It will convert it into 2 bytes, character to 2 bytes, and then will be sent to the next node. So the point I'm trying to make is, please go through those diagrams. I've given you buffered reader versus scanner. What is the advantage of individual one? Print writer versus buffered writer. So this makes it possible to attach it to any binary streams. But here, generally a beginner gets confused. So let me ask you, if I have, listen to the question, please. If I have a pure binary data, okay, raw binary data, some simple thing, just objects data, Java objects, or image data, or any pure binary data, will you be able to use print writer using some such constructor? It's a yes no question. I said, if I want to write the data in pure binary format, will I be able to use print writer? All of you are wrong. Answer is no. Because see guys, when you say print writer, it is the character which is getting split into 2 bytes. Okay, but are we writing the data in a pure binary format? Answer is no. Read it. Using the default character encoding. So wait for some more time and I'll give you powerful APIs to write the this thing, to write the data in a pure binary format. I'll show you in the lab station and all. It becomes 2 minutes efforts. One, I will write, just say numbers, 1 to 100 numbers. And those numbers, first we will write in a file using print writer, which is a character oriented writer. And then I'll write the same thing using something called as pure binary output stream, which is a data output stream. And then you open those files and then you will realize in a minute what I'm saying. So coming back to the point, let's not get derailed today. So here, print writer is so powerful that it supports the automatic flushing. Why print writer? Why I'm selling print writer to you? That's the point. So here, these are the triggers. Automatic flushing means if you enable, you saw the constructor. So if you use this constructor with Boolean auto flush enabled to true, then anytime there is a new line character appearing in the buffer of a print writer, whatever are the contents, whatever are the buffer contents will be flushed out. So these are the triggers and supports conversion from character to binary. All these things I've written in that slide, comparison slide, buffered writer versus print writer. Definitely have a look. So coming back to the point, once I have a print writer, and what will be the next this? Anyone wants to tell me? I want to write the data. So I have got the data in a buffer of a print writer. I want to write it to the text file. So which is the node stream? Answer this. So there's only one option for you here, file writer, and you'll be writing the data to the text file. It's a data sync. So this is called as data source, and this is nothing but your data sync. So translate. So let us translate it. I'll write in short forms, obviously, because it takes too much time, already spent too much time. So print writer PW equal to new print writer. What is it you are going to wrap inside? New, the file writer can be replaced by any writer. New file writer, and then you can have again some file name. We had done this. So I hope you have at least gone through it. So all these, what do you say? This is done. And now you can see this. I had copied this for this purpose. Catch-all block is same. In addition to writing, opening the source stream, I have also opened the destination stream. So tell me, change or no change? What was the earlier operation? Read from the file and put it on the console. Answer is no change. So then what will be changed? Can I continue to use this println method as earlier? Yes, that's the beauty of the why print writer supports richer API, which is, of course, write operations are there, but in addition to that, print, println, formatted printing, printf, and of course, good old write methods. So coming back, this is also the same. It is only the device which has changed. So which was the device here? Console output, I mean standard output. So that will get replaced by the print writer. So can you see this? With a tiny change and with a functional programming approach, the whole thing becomes so easy. Are we somewhat clear? I can't say completely clear because I don't know how much time you have spent yesterday on it. So that is why I spent some little more time in the, what do you say, in the revision. Okay. So then we had proceeded. We had not finished it. So we'll complete it. And then we will definitely enter the binary IO. Start. So I hope you remember read the requirement. So here, what is the question being asked? So this is typically the collection and IO. It has collection, sorting, collections, and the management, and all this is a collection framework. But earlier, what was happening before we entered IO yesterday, whenever the Java application terminates, you know, Java application is just a process running on the top of your operating system. So all those memory areas, stack, heap, method area, and etc., program counter registers, etc., they are all returned to the operating system. So whatever are the customer collections or your student collection of products and all, they are all gone. So now, if I want to save it in a permanent manner, we just wanted to write this information. Which information? Products which are present in a map. I'm just taking one data structure. You can choose anything, set, map, list, whatever. You sort it as per the manufacturing date and store it in the file using the buffering. If you want to, I had taken yesterday, Shanur, I had shown this, you forgotten maybe. See, if I want to append, so this is the file writer. This is the first argument, which is the name of the file. And here you say append flag true. Okay, so that is it. So if you open the file writer constructor parallelly, if you are having the Java docs, and here if you give the second, there is an overloaded constructor, just enable the append flag and the contents will be appended. So what is it I was saying? Right. So here, if you want to do that, how do we arrange the layers and the classes? We started with the core class product. I'll be copying what we did yesterday. So why don't I show you parallelly? Which was it? A15 was there. I'll just open that. I'll copy it into the 16.1. So you can start looking at it. It's nothing. It's an ordinary product class. We had talked about, of course, in a hurry, what do you say, discussion we'll do later. Later means looks like in advanced Java itself. So local date, manufacture date. It avoids your simple date format, and there are so many advantages we talked about. Product has a category. We saw that. And then we had written collection utils. And here I feel, okay, I hope everyone remembers from Java onwards, can you add default method implementation, static method implementation in the interface? Answer is yes. So wherever possible, what is preferred these days? Don't write unnecessary the classes. If all you have is the static methods and you don't require any data members, you can instead write it in a interface. So this is nothing great. You have it in a simple manner. And the other one is here. So this data was in the array list. Here it is in the in your what map I wanted. So what is the input argument? Focus here. List of products. I want to convert. Convert is the wrong word. I want to copy the references from the list into the map. So here is the creation of the hash map. And it is, what is it? The list is iterable. You have a for each method. And for every product P, what is it we are using? We know there is no repetitive data or no duplicate keys. So I'm directly using put. And what are the two arguments of the put method? K comma V. So we are adding the product ID and a product reference. Or of course, you can do the whole thing using something called as a collect operation. So some other time I'll show you that as well. So is everyone clear how you are copying the references from the list to the map? Because we'll be using it. And the last one was your sorting. So here, right, start looking at it. So what is the input you are giving? I'm going to change that because there are too many conversions unnecessarily. Why I wrote it in this manner? So that I'll get a chance to show you a collectors class and easy operation. Anyway, start revising with me. When you say map dot values, okay, first of all, let's say this. I want to sort the map as per the key-based criteria or value-based criteria. This is a revision of collection framework, value-based criteria. So, actually speaking, there is a method in the entry set, in the entry, Java map.entry, comparing by value. But it is little bit advanced. Advanced means little bit heavier functional programming. So I'm showing you the good old way. Good old way is what? If you can't do something in the map, just convert it to collection view. So I'll start highlighting, and unfortunately, fortunately, there is already written. So what does a map.values return? Collection of value type of references, which is collection of product. 100% clear so far? This I expect 100%. We have been doing it a long time. Then if I want to do the method chaining and I want to apply multiple intermediate and the terminal operation, single terminal operation, we convert it to stream. So this is your uh, attaching stream of functional programming stream to the collection. Next one. Now comes the important most method. So just take the cursor on sorted. Stream has a method sorted, and what it takes is our good old comparator. So one option would have been, I'm still keeping that option open. Those who are confused by this can write a good old lambda, good old, I don't know, but okay, lambda expression in the argument P1, P2, and then you compare the date P1 dot, what is that? Get manufacturing date dot compare to P2's date. So that is also legal. But I just wanted to show you something more. So here, now click on, not click, take the cursor on comparing. It will tell you comparator interface has a static method comparing. And here you can supply a function. Function is another functional interface, which will convert, which will convert, which will return the function for comparison. Okay, so what is it? What is the criteria of comparison? Is manufacturing date. So this is, another revision or another way of writing. Once again, I'm repeating at the cost of saying the same things. If you don't understand it, it's not that you have to use this API. You can scrap that and write your lambda expression consisting of lambda arguments in the body. It's equally viable. It is going to give you the same result. And here, so which is this operation? This is your attaching the source. This is your intermediate operation. Why it is intermediate? Returning a stream type of result. And now if you say, I want to collect it into some other type, it can be a set, list, map, it is already. So then there is a reduction operation, or the, what is it called? Terminal operation. And collectors is a utility class from java.util.stream. So what will this method do? It will again, so collect the stream, collects rather the stream elements into the list. So this was more on a functional programming as a revision side. But I'm saying, what is the end requirement we have? We have to take this data and put it in a what? Store it in the text file in a buffered manner. So that was the tiny part which was remaining. So here, see what I'm doing. I'll keep this method commented and let us write. Of course, I'm writing the same. Add another method. So here, to sort the map, but I don't have to. This was my intention to show you the collect type of methods, but I can return from here also. So anyone wants to tell me, what will be the return type of a sorted, stream or non-stream? What is the result of this sorted method? Is it a stream type or non-stream type? Stream type. So let us add that. Public is added automatically. It's a this. So here I'm saying, let me return from this method. Why convert? Why collect it into the list? I told you my agenda. I wanted to show you that collect method. But now, since you already know that, stream of product, and I can say, see, majority bulk is the same. So I'll just copy this and I will not simply put it in a collect it in the list. Okay. So wait a second. I'm just dropping the terminal operation. Have I done it correctly? Let me see. Just a second. Map.value stream and the sorted. Yes. So tell me, guys. I in one of the batches, all the batches I had told you to go through those ready-made code samples to understand. So tell me, at this point, have we applied the terminal operation or not yet? Answer is not yet. So stream is closed or not yet? I mean, is it open or closed? Simple. Of course, it is open. So can it be iterated over? Answer is yes. So that is the point I wanted to make. Okay, I just rewrote the example so that it is not again why attach it to the why put it in the list and then attach iterator. I can operate on the stream directly. So which part of the assignment I slightly modified. So till this, add another method. We have finished till this part. So tell me honestly, openly, whatever. Are you clear so far? Anytime you think that things are getting out of hand, you can always write it in a non-functional manner where you have for each loops or whatever I mean, and you can confirm that, okay, you are getting the output, and then you can think of upgrading it to the functional programming code, your choice. So now this is my main intention. So what is it we want is, now you tell me, does it sound better to mix up collection and IO code under the one class, one layer, or separation sounds better? Everyone knows the answer. Separation sounds the better. So this is what we are writing next. So let me close all the things. And in the utils, it is a IO utils. And like I said, all I'm going to write is static method. So I can always write it as an interface. So under utils, interface. Later, like I said, you will have DB utils and all those increase this. And here, let me mention this. So here, add a method to write the sorted product details to the text file using buffers. So start, public is already there. So I'll say write or store details, something. Store product details. Anyone wants to tell me who is going to call this method? Who will be the, which class will be calling this method? Because you have to have idea about the communication. I'm calling this IO. We are going to write this method to write or store the details. So which class will call this method? No idea, no clue. Tester is the answer. Yeah, of course, there was maybe a delay. So here, tester is definitely the answer. So can anyone tell me what should be the arguments to this method? But keep the whole focus ready. Okay, anyway, you let me see what you're saying. One is stream, absolutely correct. So that represents, I'll accept his answer immediately. So one is stream of products. Which stream? Java.util.stream. And here it is, product stream. Just earlier we created that, which is still open. Okay. Anything else? I'll require something else also. I mean, you can always hard code, but best to use file name. Exactly. So unless and until it is typically coming from user where you want to store it. So here is the file name. So with this, now tell me, what is the next step we have to do? Are we doing data read operation or data write operation or both? From Java application, are we writing the data or reading the data? Somebody said both. No, we are not reading the data from the device. I've got product data via stream. I just want to dump it to a file using buffer. So again, at the cost of repeating again, this is your Java app. Do I want a buffer operation? As much as possible, yes. So this is your famous print writer, wrapping your file writer, wrapping your text file device, node stream. Okay, just put it. Are you understanding the power of separation? While I'm in IO, I don't have to really think about my collection or anything. All I need is, okay, I'm getting the stream of products from somewhere. I don't care how sorted, unsorted, it's not my business. IO utils business. I get a file name. You just attach the chain of IO streams now and focus on writing. So just translate, it's a print writer, uh, new print writer. Are you understanding? I hope you are finding this easy compared to whatever you learned earlier. New file writer. Here, Shanur, if you want to do this, what do you say, append, can you see there is another overloaded constructor where you can take a file name and a Boolean append flag. So currently I don't want to append, but if you want to append, you can go for the next option. So this is your chain of the streams done. This is the name of the file user supplied. This is unbuffered character data sent to the sent to what? Sent to your file, but it is not truly unbuffered because it is coming from a buffer of a print writer. So this RHS represents buffered character data being sent to the file device. Now, it's a one-liner. So write that one-liner for me. We have already done it in file copy operation. I have got a stream. I have given you the print writer. So can I attach a for each? Is this stream open or closed? It's not yet closed, right? So can I use this directly? Let's try it out and confirm. Product stream. You remember, I'm just splitting it. Instead of putting together the chain, part of it, intermediate operation source in that collection. And here I'm just giving the terminal operation. What should be inside here? For every product, P right arrow is pw.println, but we can even short form it like this, shorten it like this. The moment you do this, of course, you have a compiler error. Oh, sorry, my mistake. So, I mean, that this was one of the thing. Sorry. So here, but if actually I was looking for this error. Typically the writing methods, data storing methods are void. Okay, so I just added void. I don't need to return anything to the caller. But if you take your cursor here, while writing the data, if there is any problem, which is the checked exception IO API throws is through IO. Is everyone clear so far? Oh, lagging time. Okay. So am I back? Because I did not get any warning here. Yes, exactly. So here, so is everyone clear with the method? So this is your writing method. Now just put it all together in the tester. So the last point we always write is the integration point, which is tester. So I'm saying test, collection, and IO. It's a simple integration, but at least that gives you the feel of how you can manage the things. So this is your catch-all block. Since I have not handled any exceptions earlier, might as well handle it here. I mean, you have to. Otherwise, it will be handled by JVM and about your code. And here I'll just write main over. Okay. Okay. So tell me, which all, what is it called? Which all resources I need to open with this block? What all resources I should open? I'll give you the choice. Scanner, any file devices, print writer, all of above, none of above. Answer is only scanner. I hope you understood. We have already separated everything in the IO. So there is no file handling. There's no IO handling spilt over in the tester. So it is your good old scanner and nothing more. New scanner. And here I will simply add, this is all hard-coded data. When I give you the assignment, of course, I won't ask you only to do that. You will have a proper full-fledged integration of collection and IO. I'll design some assignment and give you. And first you will do it in a single threaded manner, one thread doing the job. And then I will ask you to put it in multiple threads, that is applying threads to the similar ones. Coming back, what is it I want to do is, yeah, ask user the name of the file. Enter file name, store. sorted product details. Okay, and then we have, though then you just have to call. So tell me, which is the method we want to call? We want to call the static method of this interface. So you know your import static, utils, IO utils, and store product details. Okay, so start with that. So if I say store product details, what are the two things? Go over here. So what is it I have to pass is stream of products. So which is the method which is going to return me the stream of products? Which is the this? It is your collection utils ka method. So here, which is the method we have written just now? Sort map. Okay, I'm trying to do it in one line, nothing else. So here I'll just add the other import static utils, collection utils, start. So which is the method which is going to give me that? You don't have to remember the method names and all, sort map. And here, forget that input. And what is the other argument is the name of the file. It could be anywhere having the white spaces, anything. So I'll just say next line. Now, focus here. If you say sort map, what is the input you require is the map. So which is the method which is giving you the map? See, I'm just using the APIs together. So that is your populate map, and which finally accepts is the list. So let us finish that properly. So here it is. If you are finding it little harder, do it in different lines. There's no pressure that you have to finish it in one line. So one is populate map, and ultimately what we are passing here is the hard-coded sample data list. This is all because, okay, please don't misunderstand that every time you have to go this way. When I give you assignment, I might say that don't give any hard-coded data samples, directly add a product, remove a product, upgrade the price. It all depends on the requirement. So I think we are done. So always go from inner to outer. So let me ask you, what is this method returning? It is returning the, anytime you are lost, you can of course check it here. It is returning you hard-coded, sample list, or the list containing sample data. That I'm giving it to populate map to copy those list-based references into the map. But what will this populate map return? Sorted map or unsorted map? Answer is it is a hash map. So of course it is an unsorted map. So that is what I'm passing it to the method sort map, which returns me the stream, which is not yet passed through the terminal operation. Yesterday I spent time, at least in one of the labs, that if you use the terminal operation such as collect, reduce, or for each, or count, or distinct, or whatever, find any or something, then you cannot, then the stream is closed, then you can't reuse it. So purposefully we had kept it open, and that finally we gave it to the store product details method, which is taking the stream of products and the name of the file. So once again, I'm repeating myself. If you don't want to do this in a complex manner, you can write populate data, let it return list. Then pass that list to populate map, and then pass that unsorted map to sort map, and finally to this. But here the point was to keep it light and simple. I just use it in one line. But like I said, you can revise it in the lab session along with me. And then if you want to split it into 2-3 lines, you can. So all I'm writing here is product stored, something I mean. So we will know. So let me just run this. All I need to do is supply the file name, products data. So hardly five sample products. If it is 5 million or 5,000, whatever, it will take a larger time. You can generate larger data. And now you can say refresh. Right click on the project and say refresh. You should see the data file generated. It's a text file, text data file. So it just opened it in the notepad, and just confirm We said it with this thing, right? 2019, 5, 11, 12, and 2020. It's too small a data, but at least it tells you have successfully stored the product details in a text file using the buffers. So this was our yesterday's pending part of the assignment. Go through it. I'll not say anything for the next minute. Anything, whatever I said is not clear, please ask questions. Or any part of the code you want to see. Tell me. I'll send it your way, or I'll show you. I'll open. Trying to store. I'll have to check the code, Vipin. Anyway, today we have a combined lab, lecture lab, or kind of, parallel this. So at that time, you can share the screen. So without this thing, how can I know why it will not work? Not like this. So you'll have to show me. You share your screen sometime in the lab session. I'll definitely look at it. Okay. So any other questions than this, other than this, or on this rather? So you'll have to give it a try. Have you understood at least what went on? It's just an integration of collection and the binary. Sorry. We have yet to reach the binary, this text data. So this is it. Now I want to spend time on your binary IO, and that too on a specific IO streams. So when we say enter binary IO, let me open yesterday's slide. Which is the part which we were talking about so far, this reader and writer, we were in character oriented streams. So now I want you to shift to your input stream and output stream. Let me ask you a simple question. Which is the portable form of the data, binary or character? Portable means machine independent. Let me see whether you are answering correctly. Of course, binary. So when I take you to advanced Java, we will be generating the HTML contents from the server and sending it, because web browser understands that. But when we do the image uploading, image downloading, you will require all of that and much more in your projects. So at that time, we'll be dealing with raw binary streams. So that way, keep it clear. I'll repeat the statement again, what I said. I said in the initial part of our advanced Java, all we'll be generating from your server side dynamic web application is the HTML contents. Okay, HTML, JavaScript, CSS, whatever. Okay, and that will be sent to the server to client. Client is going to be a web browser which will interpret all those and render the output. Show it to the user. But when you actually go to image uploading from client to server, image downloading, or some database, binary large object, or suppose you have saved your resume or any image file in database and that you want to download, you will again have to come to binary streams, is what I said. So now let us enter binary streams with an objective. So the objective is similar. So what is the objective? I can take the very similar objective here. And the thing is, of course, I'm going to create a new this. I have got the product details, maybe in a hash map, in a list, or in a set. I don't care about the type of the collection. Since I'm going to use similar collection utils, I might say that it is a hash map. Okay, so I have got the product details in a hash map, but now I want to, for the portability reasons, I want to store it in a binary file. And storing the details alone is not sufficient. So we will write a proper end-to-end application where you can restore the product details from the binary file also. Okay, so this is what is the beginning of the discussion. So let's start discussing. So, okay, first thing is, let's identify your suitable streams. So the moment I say I want to write, let's start with the writing first, and then opposite things will be done in the reading. So one end is Java application. I'm not drawing because it takes again a lot of time. So, but I think you can understand it from here. I want to write the data. So can even wants to tell me, what should be the stream? Output stream, Akash, Pratiksha are the abstract classes. So I can't instantiate the abstract class. So which is the class exactly? Which is the class which represents the binary data to be sent to the file is a file output stream. Absolutely right. So here you can use a file output stream, and file output stream is going to wrap your binary file, and this is fine. This works. This is legal. So tell me, when I use this file output stream, is it a is it supporting buffering or no buffering? Does it support buffering? Answer is no. It doesn't support buffering. So if I want to do the buffered data write operation, anyone wants to change this? So this has to be modified. So tell me the modification. Which is the buffered stream you can put? I hope you have four options. One is buffered input stream, buffered output stream, buffered reader, buffered writer. So the suffix is the output stream, and what is the prefix is generally tells you the functionality. So answer is here I will add buffered output stream, and here is the file output stream. Okay. So how do I translate this into Java code? I hope everyone can. So all these are auto-closable. I'll just, say it verbally. So try with resources. Buffered output stream out is equal to, tell me, new, which will be the first node you will be instantiating, buffered output stream. I'll show you in a minute. Buffered output stream says, I am a binary data storage. I'm a binary style buffer. So what will be the constructor argument? Can it only store file output stream? I mean the data from binary file, or any binary data from any device? Answer is binary data from any device. So this is output stream, and file output stream is output stream. So that matches perfectly. So what it will be anyway? Two way. So I discarded talking about it. So I'm saying buffered output stream out is equal to new buffered output stream. New, what is it you are going to wrap here? File output stream. And the constructor of a file writer and file output stream are the same. So what you can take inside is the file name. Are you getting this? So you can think of it and then write some code here. So go from inner to outer. This is your name of the file. What does this represent? Unbuffered binary data, raw binary data, pure binary data, unbuffered binary data to be sent to the file device. And this is the data coming from a buffer. So now the RHS of this statement is buffered binary output stream connected to the file device. Are we clear so far? Because if this itself is not clear, you won't understand anything further. Okay. So now tell me, when I start writing the code in my try with resources block, whose methods I'm going to call? Are we going to call the methods of buffered output stream or file output stream? BOS or FOS? B or F? Of course, no, file output stream, somebody said. The file output stream is hidden. Which is the closest node? What is it we have got? We have got the variable out, and that out type is of the buffered output stream. So don't make the mistake like this. So now open here buffered output stream. So if you see this, you can check the hierarchy. So you can see this output stream, filter output stream, buffered output stream, etc. And it is an auto-closable one. It implements buffered output stream. Application can write the bytes without causing a call to underlying system. Underlying system means underlying peripheral device for each byte written. It stores the data in a buffer. When the buffer is full, or you flush out the contents, or you close the buffer, the data is sent. But the point is something else. Okay, so I hope you understood the description. Just click on the method here somewhere and have a look at the methods. So tell me, I hope you have come here. I mean, you have opened your Java docs, and otherwise refer to this. So what are we looking at? Are there any powerful methods, or are there couple of write methods? So as the answer goes, all you can see is couple of write methods. So one is write int. Don't worry, it's not going to write 4 bytes. It is going to write the 1 byte only. So most significant byte or the least significant byte, LSB or this MSB. The answer is least significant byte. But the point is only 1 byte. Here you will say, oh, I can write the byte array from whatever offset and number of linked bytes. Of course, yes, agreed. Here, if you click on the, what do you say, inherited method, you can see you can write the byte array. So now hear the question carefully. Because that is how the opening statement is. I cannot directly take you to some streams and say that you have to use it. You have to justify, right? So let me ask you a question. If you use buffered output stream, who will have to, okay, I'm just phrasing, who will have to convert, I'm saying, listen to this. What is it I have got? Let us focus on one collection, any collection. Let's say hash map. So who will have to convert this hash map of products? I's product ID is integer, I comma product, integer comma this, whatever. Integer to this, to what is the only what are the only write methods we have? Your this bytes oriented to bytes or byte array. Answer this question, please. If you decide to use buffered output stream as per this, who will have to do this conversion? Answer is programmer. Absolutely right. So here, this is such a huge effort. You can't even start guessing it. See, I have got a hash map. So I'll have to attach an iterator. I mean, you can't attach it, but now you have got for each method and all that. Then you go over every key and a value pair. Then you take, suppose you say, okay, I don't want the keys because anyway product ID is there in my value. Fine. So you say hm.values, just a small detail. But then you have got a product ID. Let me not talk way. Let me open this. So you'll get an impact of what is it I'm saying. Otherwise, all this conversation sounds very superficial. Coming back to the point, here I have got the product ID. So here, what to what conversion you will have to do, guys? Into 4 bytes conversion. Programmer has to write a method. So you will have to mask those bytes. I mean, you will have to mask the what is it? First 24 most significant bits, and it with mask the last ones 1 byte and get it, and then shift right and get the whole data. In short, let me not go to so many details. Who will have to convert from integer to 4 bytes? You, programmer, us programmers. You will have to convert string to bytes. There is a method in the string class get bytes, but you will have to do it. Who will have to do the, I mean, kind of very difficult conversion? Category. So category is a enum. So the twisted effort. So category is to string, convert it to string, and string to bytes. Can you imagine the hassles? Add the date and the price. So everywhere a programmer will be hassled, more than hassled, and will have to perform the conversions. So what is a better suggestion naturally? Using, I mean, doing all these conversions ourselves or using the sophisticated advanced API? 100% let Java do it. Okay. So that is where we are using the high-end APIs, or I mean, there are filtering streams now. You know about node streams. You know about which streams? Buffering streams. Now I'm talking about conversion streams. Okay. So a bit of what? A bit of a step in between. I'm not jumping still to object streams. So here everyone agrees it is programmer. So which are the streams? I'm literally writing as a question answers. Which are the conversion streams? So there are plenty of them. I'm just telling you the famous ones. So one of them is data output stream. And the other one, the opposite one is, of course, data input stream. So when you have a typical, I mean, they always work in pairs. One will do the job of writing, one will do the job of reading. So if you see the of methods of data output stream, these methods are for converting what to what? Converting primitive types. Which primitive types? Everyone knows all primitive types, and also strings, because you require strings very often, to binary. So if you open the data output stream class, you can do it in the lab session or whenever you want. You will see data output stream has got all this is written in my readme IO is having the methods which will take the primitive types or strings also and convert it to bytes. Without example, things don't become, I mean, you don't understand it. So there is a method. Right methods are all void returning. So public void, and I'll just take one or two. There's a method write int I mean int data throws. Anything can go wrong while writing. Throws IO exception. So tell me, if you create the instance of the data output stream, what is it I can pass here as an integer? Product ID. And who is going to do this conversion from integer product ID to your 4 bytes? Answer is data output stream. And those 4 bytes will be written out to the next node. Similarly, is this the only method? Of course not. Open data output stream and you'll see so many. All, all write long, write short, write float, write double, all these exist. Plus it has got a method, write UTF. UTF is Unicode text format. And here you can pass a string. And here it will convert the string into UTF-8 format, not UTF-16. It converts it into UTF-8 and does the conversion. So then, now what will be my chain of streams look like? So I'm taking this here, and I'm too lazy a programmer. I don't want to slog when there are obvious solutions, when there are good solutions in the market, in Java API. So can you tell me? I have to fit the data output stream, conversion stream somewhere. So where should I fit it? So tell me, the updated chain of streams. Anyone wants to tell me? So where should I add it? I'll tell you the clues. The point is here. I mean, first option is here. Second option is here. Third option is here. Can you please pick up the option? I already got it from Shanur. Very good. So the point is here, whose methods you want to call for conversion? Data output stream. So it has to be the closest to Java application. If you put it in between, again you have got a buffered output stream, and again you are writing, limited to writing everything in bytes. So here, 100%, this is your data output stream. What is it we will give to the data output stream? We will have to convert that product. You'll have to attach the iterator, I mean, for each and all that. You'll have to extract the product ID, the product price, etc. You will get the product category as a enum, convert it to string, overriding form of the toString, and then write all the details. Date also. Local date has a toString. So everything you will convert it to, I mean, data output stream will convert it to bytes, and then it will be written, added to the buffer of a buffered output stream. And whenever buffer is full or flushed out or closed, the data will be written to the binary file. So tell me, if I ask you, what will you call file output stream? You have 3 options: conversion stream, buffering stream, or a node stream. You can take C or B or N, whatever. What will you call this? I hope people are clear. Of course, it is a node stream. What about this? It is a buffering stream. And here is the conversion stream, which can take any primitive type, including the strings as well as the strings, and it will convert it to binary. So is this chain clear? This is an example of all 3 different type of streams working together to give you the complete output. Got something or not clear? Are you somewhat clear? So here This is one of the approach. And of course, what you read, whatever you have written, you have to restore. So anyone, for restoring. Restoring means reading back. For restoring the details, product details. Anyone wants to tell me what is it I'll have to do? So one end is Java application. The other end is the binary file. Now we have shifted from text to this. So start adding it always from file to this. Anyone wants to tell me? Am I doing the read operation or write operation now? Read operation. So what is closest to the device is the node stream. Anyone wants to tell me which is the node stream I should use? It's just the opposite. Globally replace write by read and you are done. So here it is what? File input stream. Okay. But suppose I want to do the buffering. So what will be, which will be the buffer stream here? There earlier it was buffered output stream. Here it can be buffered input stream. And here, do I want to take the pains or the efforts of data conversion? Absolutely not. Byte to primitive types or restoring byte to strings and all that. So who is going to do this restoration? Data input stream. And then I can attach, data input stream to this Java application. And like how I told you, there are writing methods. There will be opposite reading methods, read int. So I'll just take one example. When I say, okay, so you just imagine that you have translated this and the name of the variable of data input stream is in. So when I perform in dot read int, it is going to return you the integer. The return type is integer. But I just want to spend a minute on making you understand. When I say in dot read int, can anyone guess how many bytes your data input stream will read and from where? So first question, how many bytes it will read, guys? It will read 4 bytes. Why they are saying 4? One integer in Java is how many bytes? 4. But from where it will read? It will read it from the buffer of a buffered input stream. It doesn't have it doesn't have to go all the way to the device. The data is already there in the buffer. So first 4 bytes, wherever is the pointer, pointer starts with the 0th index. So it will read the first 4 bytes, convert it into integer and give it to the programmer. Next, whatever we have written, if you follow the sequence here, suppose I have written the name. So which is the method for writing the name? Write UTF. The opposite method is read UTF. So I will be gathering. So for example, you have to follow the same sequence, of course. Otherwise, the data will be garbled and sometimes you might get the exception also. So this will consist of all read methods. This will give me one product restored. So I will have to take these such products. I'll have to put it in a loop till the end of file or something. So all these products, then I'll have to populate into a hash map. So even with these advanced streams, data IO streams, when I say data IO streams, what I mean, data input stream and data output stream, you will have to read the data in units of primitive types or the strings at the most. You will have to put it in the product detail. And once you create that product instance, you will have to add the reference to any suitable collection, including a map. Are we clear so far? Read UTF before readint will corrupt the data? Absolutely. Absolutely, yes. Because read UTF has the number of bytes. Okay. So the integer data will be misinterpreted as length and the whole chaos will be there. And if that gives you something which is beyond the end of file, you will get an EOF exception also. So two possibilities are either wrong data, not corrupt the data, it is reading. So how can you corrupt the data while reading? What you mean is basically wrong data read, or sometimes you might get a EOF exception, end of file exception. So coming back on the track. So here, okay, whatever I said, is it clear or not clear? The reading part and the writing part. So here, piped input stream for device like pipe Sonakshi and buffered input stream for buffering. So they are totally different. I mean, one is node stream, piped input stream, and buffered input stream is only for buffering. So here I'm saying still so much of it is still done by the programmer. Okay, the tricky part, the hard part, binary to primitive types and strings. Who is doing it? Java or programmer? Java API, J, P programmer. Answer is Java API. But who has to still put all these data items together in a product and populate the map is still a programmer. So what can be the best out of the whole deal? I don't use any of it at all. We directly use some advanced stream classes which can directly write the object to the binary stream and which can restore the entire Java object from the binary stream. If that is not sounding impressive enough, see, hash map is an object. So I'm not restricted. When you understand the last part, which is object streams, where I'm not restricted to a single product. I can write, listen to the capabilities, why it is so favorite, so popular. I can take the entire hash map and I just use a method. There's a method, write object, read object, and all that. I can use a single method, and it is the JVM who will extract the state, who will extract the details, convert it to binary, and send it to the file or a pipe to a socket wherever we want. So that will reduce all intermediate operations also, and we will be able to get directly, we will be able to deal in objects directly. So that, of course, this is the most advanced streams in Java IO. So what we are entering is object streams, and there is a very important concept of something called as serialization and deserialization. So this is mark it as an important topic, please. And here I've given you the complete readme about serialization in detail. Only part of it I'm going to cover. Whatever is in your contents, of course, I will take. They've just mentioned one bullet point, serialization and deserialization. But we go little deeper, but additional information is all here. So do read. So let me show you what we mean by that. So just a second. Okay. So you need to understand the part first, and then why I said it is important, because it is going to, you are going to revisit it in advanced Java also. So here you have got a Java object, which could be a product, which could be list of products, array list of products. Array list is an object, which could be hash map of products, or I don't care, array also is an object. So you have a Java object and you want to store the state of the Java object. See the word I'm using. Everyone knows object has state, behavior, and the unique ID, which is the part of the state. So which part will get converted? Which part will be written out to a binary stream is only the state part. All of it will make sense little over time. So coming back to the point, the state of the object can be extracted, converted into binary. So it is object to binary conversion. And once I have a binary stream, can I write it to the memory? Yes. So those are memory-based streams, byte array input stream, byte array output stream, etc. You don't have that. Can I write that particular byte stream, or can I write the Java objects directly to database? Of course, yes. And that is one of the most interesting frameworks, ORM frameworks, object relationship mapper, Hibernate, which is part of advanced Java. So today what I'm showing you is the object to convert it to binary, and that binary stream will be storing it in a binary file. So this is the path we are taking. But using the same serialization and deserialization techniques, you can write that binary stream, you can route it. You can route it to memory or the socket to send it to your server or to database or to file. So the conversion, listen to the simple words, simple statements initially. So what is the serialization? Serialization is the conversion from Java object to binary. The detailed statement is converting the state of the Java object into byte stream is your serialization. But why the weird name serialization? Serialization is in serial numbers. So when I show you the structure of that binary stream shortly, you will see that actual numbers, it is stored in a sequential manner. So that is why the name serialization. And just storing the data in binary file is not sufficient. You have to restore it back. So for restoring, which to which conversion will require? Binary data or byte streams back to reconstruction of Java objects, and that is known as deserialization. So object to binary serialization, binary reconstructing into Java object, and not only single Java object, the complete object graph, as in what? Hash map has a key and a value. Key is a product ID. Hash map has a product as a value reference. Product has a manufacturing date. Product may have a shipping address. So you can imagine the entire graph can be stored and restored using this serialization, deserialization technique. So I hope at least you got to feel that these are definitely advanced streams, advanced operations. So now let us start looking at this in detail. So first is everything starts with why. Read this much. Okay, read this much at least. I'll start explaining. So let's go line by line. What is the need of these object streams? One word answer: to achieve persistence. So the same persistence, you are going to hear it once again in advanced Java in form of storing the state of the object in the database via Hibernate framework. But the concept is the same. Today, we don't have database. Today, we don't have any ORM tools, object relational mapper tools. So all we'll be doing is taking the Java objects from the heap and saving the state in the binary file. So that is the focus today. Over time, we'll discuss different forms of persistence. Coming back, wherever you go, what is the meaning of persistence? Persistence simply is not this. Saving the information in a permanent manner is persistence. But what is Java persistence? What is the persistence meaning as specific to Java? Saving the state of the Java object in a permanent manner, which could be on a binary file, which could be in the database, which could be sending it, uploading it from client to server, and then putting it on the server side database, anything. So which is the persistence unit, which I'm showing you today? Only binary file, one thing at a time. So read this twice if required. If you did not have these object streams, serializer and deserializer stream, as a programmer, I already explained you the whole process. You have to extract the details. You have to convert it to the binary format, and then you can store it to a file or to any device. But when you start using object streams supply ready-made methods for the same. Okay, so that is the heart of your discussion. So I'm going to start showing you the serialization, that is the writing part. Will have the binary file which has the state, which has the details. And then once you are settled in binary, the writing part, then I can show you the reading part also. So read this. Which is the class for writing the objects to a binary stream? The name of the class is object output stream. The moment you hear this as a name, tell me, under which hierarchy you will put it? You know there are 4 hierarchies: input stream, output stream, reader, or writer. Everyone knows the answer. See, you don't have to like think or memorize or remember. It is ending in output stream. So what it means is binary output stream. So first statement, is this serialization deserialization available in binary world or character world? Answer is only in binary. There is no equivalent object reader, object writer. So all you can convert the state of the Java object only to the binary streams. Okay, so now read further. There are these two important interfaces. There are others also, but I'm just giving you two. So object output stream class implements data output interface, object output interface. This data output interface is also implemented by the data output stream, which allows it to write the primitive types. But I don't want to just feel happy by writing primitives. So there is another interface called as object output. And that is where, I mean, so many methods it has added. One of the important most method is write object. All will be clear the moment we start writing. So now read this. First, I'm going to handle it at a API level. So everyone should be able to, I mean, the API part is so easy. It is so direct, so ready-made. Anyway, read this. Let me not disturb you. So which is the class which is going to perform this serialization? Answer is in front of you, object output stream class. And what is this so-called conversion? Serialization is conversion from object to binary. But object has a state and a behavior also. So which is the part which will get converted to binary? Is it a state? Is it a behavior? Is it both or is it neither? Answer is only the state. So when I take you to deserialization, it's a popular question. What are the prerequisites? What are the things you will require for deserialization? At that time, I'll answer properly. So currently, remember, it is only the state of Java objects plus some additional metadata information. So what is that additional information? It's a huge readme, long readme, I mean. So in addition to, so what actually gets converted is this detailed format. So here there is a Java specific magic number, first 2 bytes. Then there is a formatting version number. And here, this is that metadata class description, which contains which is the class you are serializing. There is something called a serial version unique ID. There will be the description of data members. And finally, the state of the object will be stored. So I'm saying it is little complex process. So focus on it in simple sequence. So coming back to the point, what does object output stream perform? Serialization or deserialization? Answer is serialization. What is the conversion from object to binary? What exactly gets converted? Is it a state or is it a behavior? Answer is it is the state. Okay. And in addition to state, of course, some additional information also is maintained in that binary stream so that a deserializer object input stream can take that information from that serialized binary stream and restore it into the object. Okay, so serialization is only this much. Now, when you say serialization, it is going to arrange your data. It is going to keep your objects, the state of the object, in a sequential manner. That is why serial numbers, you know the term serial numbers. Serial is something which is arranged in the sequence. That is why the name. And one of the most important statements of today is what is actually referred as, what is actually considered as the state of the object. So one half you already know. What it consists of, static members or non-static data members. Everyone knows we have spent so much time on static and non-static. So it is non-static data members. Where are static members memory allocated and how many times? Method area, once per class loading. So of course, in the state heap, there is non-static members. And today you will learn another keyword in Java, something called as transient, little later. So the perfect answer, the clear answer, or the correct answer is non-static, non-transient data members. Don't ask me now what is transient. We will look at it at a proper time. So what is it which is converted to binary and can be stored in a binary file or wherever? Answer is the state of the object along with some metadata information. Keep the highlights, keep the broad points with you. Now, let us come to the actual, some API. So where you understand things. So you have to understand the constructor. How do you create this? It is a concrete class. Of course, can be instantiated. So read this. Read the constructor part. I'll discuss. When you say output stream, what it means is any binary output stream. So let me ask you a question, simple question. If I want to convert the entire hash map into binary and store it into a binary file, can anyone tell me what will be this output stream replaced by? Exactly, Mauli. So give me time. Let me come to deserialization and you will understand. But what you are saying is absolutely right. Answer to your question is yes. Okay, answer that. I was looking for the answer. I said, I want to take this, some product details in some collection and all, and I want to convert it into binary and store it in a file. So can anyone tell me what will be this argument then? When I talk in file, which are the four options, guys, you have? File input stream, file output stream, file reader or file writer. Which is the option? Of course, file output stream. Because we just now said that serialization, deserialization is only for binaries. And I want to write the data. So I expected a faster answer. Of course. So this is file output stream. But if I change my mind, not my mind, but change the business scenario, and if I say this serialized binary stream, I had to send it from one thread to another thread. So can you tell me what will be the argument replaced by? Input you are mixing up, Nikhil. I want to write it. So what is the name of it? I don't expect the memory. Piped output stream. Are you getting this? I see I'm writing a distributed application and I have got the map of hash map of products from my shop and I want to put it on a centralized server. In short, I want to send it from client to server. What will be this output stream replaced by? Socket output stream. Are you understanding? So the destination, what is the argument here is nothing but the destination binary output stream where this serialized data stream has to be sent. So can I send it to the file? Yes, using file output stream. Can I send it to another thread via pipe? Yes, piped output stream. Can I first put it in a buffer and then send it to some device? Answer is yes. What will you replace this by? Don't give me wrong answer. Give me prompt answers. I said buffer. So which one? Of course, buffered output stream. Are you understanding? The flexibility. Same. Upcasting. Inheritance. What is it? The super type reference can refer to any subtype. So I can replace it by piped output stream, file output stream, what is it, your print stream kind of a thing, any binary output stream. Okay. So this is about the constructor. Tell me, what is the job of this object output stream? I'll give you three options. Wrapping the device, conversion, or buffering, or all of above, none of above. I hope pretty easy answer. It is a conversion. Are you understanding? We are talking about a superior advanced converter which can take a Java object or collection of objects as a collection of references and convert it to binary. So I hope people are clear there. Now look at certain methods. Since object output stream is implementing, where is my implementation? Yeah, implements data output. These are the methods you already have. So if you want to write a simple integer, a primitive type, a character, or a float, or a double, or a string, I have the methods write int, write float, write long, write short, etc. But The whole idea is that I could have done it with my earlier class data output stream. So which is the major addition? Major addition we have here is the write object method. And here you can see this. It's a simple one-liner, I mean one API, but it's so powerful. You'll see the power in a minute, couple of minutes. So here we have write object method. And what is the argument of it is the universal superclass. So tell me, can I say array list is an object? It's a true false. I mean, yes, no kind Boolean question. Of course, yes. Can I say my tree set is an object? Yes. Can I say product is an object? Yes, yes to all. So in short, can I replace this by list of products? Yes. Set of products? Yes. Or whatever, map of products? Yes again. Or I can, if I want to store a single product detail, I can replace it by product itself. I hope you are getting the feel of the advanced nature of these streams. So what is this is the real deal, but I'll come to that in a short time. You'll of course see that. But the other thing is, while conversion, while writing this to the next node, if there are some writing time errors, IO related errors, then it will throw you IO exception. Don't ask me this because we are going to see it and then we'll step back and we'll understand. So instead of, I don't want to take you to deserialization so fast. Let us settle on serialization first and then understand the next thing. So let me open some, I want to start with the threads. So I'm giving you some ready-made diagrams here, drawn earlier. Wait a second, what is it? This is your thing. Store the data. Okay, here is the thing. Take a look at objective, which is what we are going to solve. So what is the objective? Store the data from any suitable collection, be it a list, be it a set, be it a map, to a binary file. I'm saying write the data from Java application. See here. It can be a map, it can be a set, it can be a list, it can be sorted, unsorted. We don't really care. So understand the arrangement of the streams. Because once you understand that, translating it to Java code is like 2 minutes efforts. So start. This is your Java application, which has a data in a suitable form of collection, and the other end is the device. So here, the converter, the most important stream is the object output stream. So object output stream, can you tell me? Let me start asking you questions. So if you ping here, if you peek here, what type of a data can you pass? I'll just ask you questions. Can you send the primitive types? Answer is yes. There are methods, write int, write short, write long, write double, etc. Can I send the strings? Yes, there is a method write UTF. But that's not my point. Point is, can I send the entire map or a set or a collection and call write object method? Answer is very much yes. So see this. Start reading. Object output stream is coming from binary output stream. This is identified as a serializer. So what is serializer? Who is serializer? The one which does the, whoever does the serialization. So what is this so-called serialization? A process which will convert typically primitive type strings and all can be done with the data output stream also. But mainly we are interested in objects or object graphs or the collections, total collections to a binary format. Okay. So what it does is this is just acting like a filter or a convert. Filter is a, I mean, confusing term. Converter is the better one. It simply does the conversion from objects to binary. And then if you want to route it, if you want to store it to a file, attach file output stream. If you want to send it to the socket to be sent to the server, put the socket output stream or piped output stream and likewise. So tell me, what is the type of the data here? It can be primitive type, it can be object, it can be collection of references and all. But if you put a probe here, what will you get here? Answer that. What will be the output here? Binary stream or a character stream? It's a binary stream. Will it be buffered or will it be unbuffered? Answer is unbuffered. Object output stream says, my job is simply a conversion. I'm not going to give you buffer. So if you want to add the additional buffer here, what will be the what will be the stream you will be putting here? Buffered output stream. But I'm telling you from experience, when you use object output stream, you will end up using one method, write object. So there are not multiple write operations. So you can skip in most of the cases buffering. But if any requirement talks about buffering, you can insert a buffer here. Buffer means buffered output stream. And then I want to send it to the file. So here, file output stream. And then that can be written in the binary file. So this is what we are going to explore in the next minute. Is the chain clear? Is the chain of IO streams clear? Okay, better question. Forget what I said. Just translate into Java code. So before you start the translation, are these all auto-closable? 100% yes. So imagine try with resources. Which is the closest stream to the Java application? This converter. So I'll say the left hand side. Object output stream out is equal to. Tell me the LHS, please. I am so sorry. I said the LHS. You give me the RHS, please. Object output stream out is equal to. Tell me. I think you are typing. I hope you are typing. Absolutely correct. New object output stream, new file output stream, having the name of the file. And that's it. That's it means that finishes the first step. And then we will use the write object method and we'll see whether it works or not. Of course, I hope you understand that things are not as simple as this also. But everything should be observed and then concluded. So let me create a new project. I'll just copy this. So we'll create one for serialization D16.2. Let me remove this. This is all text data. So I'm deleting that text data file and observe what I'm doing. I'm not touching the core classes. Tester will talk about it and utils. I'm just thinking about it. Wait a second. So collection utils. I'm just thinking whether to go for all that jugglery. Let's not do that. So here, see, I'm slightly changing. Changing means not touching here. We have so many methods. So I'll be using the populate map method. And what goes in is the list of products. What it returns is the map. So let it be unsorted map. I'm okay with that. So here, I'll open this and tell me change or no change. In this case, I want to show you the serialization. So this code, change or no change. First basic question, respond fast. 100% there is a complete change, right? So here, just observe what I'm doing. So I'll add a method to write what? The product map. Unsorted, let it be unsorted. Later, anyway, we are starting with threads. So we can have threads plus collection plus IO and write a, more advanced Java application. So let it be unsorted. Product map to a binary file using serialization. Okay, so I'm saying static void is fine, store product details is fine. Here, I'll replace this by a map. If you are wondering why she's not working on the stream, I'm saying you don't have to iterate. I will take the hash map as an object and directly dump it, directly give it to the serializer. That is why I'm not going to the streams and all. I have a better API now. So I'm just giving this, calling it as a map, and this will be written from scratch. Are the changes clear? So I'm still taking from user the name of the file and I'm taking the map. And earlier, I hope you remember, we had to attach the stream. We had to go over the for each. For each is what? Internal iterator and write record by record. You will see the whole thing will disappear. So just as a quick revision, I'm writing it here. So anytime you are revising in the lab with me, you will know what is happening. So Java application, which is the next node. Node means not the node stream, which is the next stream you are going to open is object output stream, which is the converter stream, which is the serializer, right? And that is going to extract the state of the object and convert it into binary. And then I want to send it to the node stream, wrapping your binary file. I hope you are clear so far. You just have to translate into Java code. So what is it? You already told me earlier. So object output stream, let's say out, new object output stream, new file output stream, because I want to today's put it in a file for persistence. Later you can send it to whatever device you want, and that is your file name. Okay. So I hope you are clear with the streams. All I'm using is the node stream here, no buffer, because everything is going to get over in a single write operation. Only one write operation I'll be using. And that write operation is there any need to attach iterator, go through the stream, record, element by element? Answer is no. The method which we are going to use is out.write object. Tell me, what is the argument I'm going to give here? What's the argument there I'm going to add? Of course, a map. So this is what is to be written is the map. So I add this, and then you can see here, I have already said throws IO exception. So I'm telling the compiler I'm not handling it. My caller will handle it. It's a checked exception. So is the method so far written clear or not? Is it going to work or not is a different situation, different kind of question. Whatever I've written, is it clear so far? Which streams and all that? Okay. So I'm telling you, API level is very easy. Of course, there are some catches. So here, now, let me, of course, my earlier tester will not work. So this part remains the same. Enter name of file name to store the sorted product details. And here I will just change this to, sort map I don't want to. So something like populate map, which takes the populated list. This looks, because I'm using it from the earlier written code. Please don't mix it up and think wrongly. So here what else I'll require is populate data and the file name. SC dot next, or you can say SC dot next line. Are we done here? Okay. So now a small detail. Typically, when you are writing it in a serialized manner or serialized binary stream manner, the extension of the file we give it is .ser. Can I replace it by .data or .info or whatever? Answer is yes, it works. But the norm is to give it as .ser. So just in a minute, check what is happening. This is where the name of the file will be accepted. This is where what this is returning is the list, because I had the data in the list, and I'm just copying those references in the map and giving it to the IO method. So let's try this and you'll see something. Of course, like I said, things are not as easy as this also. So suppose I say products.ser. The extension .ser is for indicating that what is going in that file is the serialized binary stream. Not compulsory, but recommended. And this is your opening statement. This is where you start actually understanding things. So simple question, simple answer. Is it working or not working? Obvious. Answer is it is not working. And this is one of the popular questions, which is the exception you are getting is not serializable exception. It is, of course, from java.io. If you trace the hierarchy, it is a subtype of IO exception. So now let us start understanding detail. Okay, by the way, it is telling you not serializable exception and which is the class it is objecting to. Is it objecting to Java built-in classes or UDTs, user-defined type? This is our own type, user-defined type. So just keep it in mind and read further that serialization readme. So I hope you remember seeing this. I said I'll not explain now, but now is the time. I'll just start this discussion not serializable, the exception when. So here, other things you are already read, ability, for persistence and all. So now start reading from this line onwards. We have already felt it. We have already identified interfaces are so important in Java to Java programmer. So now I'm introducing a new interface. Just read this, please. So the entire serialization and later deserialization revolves around a single interface. And what is that name of interface? Java.io.serializable. So keep it light and simple. So serializable interface will be used for either allowing serialization or not allowing, aborting serialization. Okay, so read this in a little slow manner. What is the meaning of the statement, above statement? At the time of serialization. So please always sync up with the code. That is how you should be doing this. So at which place, in which part the serialization is happening? Don't say here, because here you are just attaching, you are just preparing the chain of the IO streams. But the actual conversion, actual serialization is happening here. Okay. So this is where your serialization is happening. So now read further. At the time of serialization means whenever you have said out.write object, or later after the break, when I show you deserialization, you will be using object input stream and you'll be using in.read object. So either at a serialization time or later during the reverse conversion, who is going to check? Answer is this is beyond the compiler. So this serializability, whether this object graph, whether this is serializable or not serializable, this is not checked by the compiler. It is checked at the runtime. So JVM checks if the concerned object, if the argument of write object, is it serializable? Means what? What is, how do we propose that is a relationship? Has it implemented? See, this is not generics. So compiler is still not clear. It is all done at the runtime, checked by the JVM. So has it implemented serializable interface? If the answer is yes, then only it will proceed. Otherwise, it will throw the exception. And the name of the famous exception is, this is your fully qualified name. The name is not serializable exception. But the point is, here, serialization is like your database transaction. You'll be learning database soon. So database transactions are nothing but group of SQL queries, which as a whole works or as a whole doesn't work. So coming back to the point, serialization is all or nothing. Meaning, anytime JVM during the conversion comes across a non-serializable node, is it going to continue with the serialization or is it going to completely abort the serialization? C for continue, A for abort. Answer is it is going to totally abort the this thing, conversion. So when I said it checks for the serializability and all, you have to again sit with the code and understand me. So tell me, what is the argument of the write object? It's a map. Okay. So here, literally, but you know, map is just a interface reference. What is it actually pointing to? I think we got a hash map or something. Yeah. So how do you check now? Now open the Java docs. With Java docs, things are so easy. And tell me or look it up yourself and answer. Is hash map serializable? Answer that. I have not yet shown you that serializable interface. That I'll do towards the end. So tell me, is hash map serializable? It's a yes or no question. It's of course a serializable. So the first node, the outermost object, passes the check of serializability. But JVM is stricter. So JVM says fine, great. Now what? What is map consisting of? Entries, key and a value pairs. So it will check integer. So now you do the exercise. All wrapper classes, all string handling classes, all date time handling classes are serializable. So tell me, will it have a problem with integer? Problem or no problem? Is integer serializable? Answer is yes. So continues ahead, goes ahead, and then it comes to your value type and it will just check and everyone knows the answer. Is our product serializable? I've not even told you what does serializable look like and all that. So product is not serializable. So what is the formal statement? Anytime during serialization or deserialization, if the JVM comes across any non-serializable object, is it going to continue with that partial conversion? Answer is no. Entire process of conversion is aborted, throwing you which exception? Answer is java.io dot not serializable exception. So it is all or nothing. So all the entire object graph which started with hash map, then hash map to key, integer, product it fails because product is not at all serializable. So now read further. So here, what is the solution? Anyone can give me the solution. What is the solution? Simply make product class implement serializable. What else? Right? Make it is a serializable. And then you come to the moment you say an interface, a class implementing interface, what is the next question you should ask to Java docs is which methods I need to implement. So here is the answer. Read that. So as a surprise, as a surprise means parallelly do that. It is compulsory. It is compulsory reading to everyone today. Okay. So you because a whole so many good answers are here. So I'm opening java.io.serializable interface. You can see this okay anyway warnings we'll talk about later. The what are the disadvantages of serialization and all that it covers. And if you check here, you won't find any methods. It's an empty interface. Okay. So the interface, it will tell you so clearly. Read this carefully. Serializability of a class is enabled by implementing java.io.serializable interface. What is it they're trying to tell you in simple English? If your class has implemented serializable interface, allow serialization, otherwise stops it. Next one. This warning part later, secure coding lines. Anyway, so read this. The classes that do not implement, can their objects be serialized or later deserialized? Answer is big no. So see, I'm making you read line by line, all from Java docs. So what is compulsory for you to implement this? If your super class is serializable, what will happen to subclass? Is it implicitly, is it automatically serializable or not? Yes or no? It is automatically serializable. Vice versa is not true. If your subclass is serializable, superclass is not, and there you have to take extra efforts, special efforts. And the most important thing is this line. Is it an empty tag or marker? All words mean the same. Is it a marker interface, tag interface, empty interface? 100% yes. Doesn't declare any data members nor neither fields or data members. The whole idea is to supply a runtime marker. In short, who is going to look for this serializability? Compiler or JVM? It's a JVM. And JVM will check whether the entire tree, entire object graph, not tree, entire object graph is serializable, allows serialization, otherwise doesn't. And of course, there are a lot of rules. So before taking a break from this, quickly tell me a solution. Everyone knows the solution. What is the solution? It's all or nothing. So make your product implement serializable. And if you looking at it carefully, all you get is a warning. So what is that serial version unique ID? After the break, I will discuss, of course. But point is, are you seeing any errors? No, because serializable interface is just to provide a highlighter. You know the concept of highlighter panes. So, if any important contents and all you want to quickly go over and all earlier day before exam or whatever, you just highlight. So this is like a highlighter. This is like a marker, runtime marker meant for the JVM. And then to cut the story short, let me run this again and something. Like I said, the norm is to give it as a .acr, I mean extension. And as you can see, exception or no exception. Of course, no exception, because now the entire graph, object graph is serializable. And when I say this, product class is serializable. But what about the state? It is only the state which is converted. So tell me, what are these? These are the primitive types. So primitive types can be directly converted to bytes. So primitive types, there is not an issue. Start answering. Is string class serializable? Answer is yes. String, string builder, string buffer, all are serializable. What is category? Category is a enum. Everyone knows that. Which is the superclass of a category? Java.lang.enum. Open that and check. Enum is serializable. If your superclass is serializable, so is your subclass. So enum also no issues. What else we got? Local date. So you can open that local date. This is from what do you say, internal. You can check that is it serializable? Answer is yes. So now your JVM is happy in the sense it finds all the nodes, all the objects. Where is that? Yeah. So the entire stream, entire object graph is not containing a single object which is not serializable. So the serialization continues. And if you see, if I just refresh this, you can see there is a product.ser. So what do you expect to see? Binary content or the character content, text or binary? A binary file. And am I asking you to read this binary file? Absolutely not. But you can still get the point. So I'm not expecting you, but there is a magic code, there is a serial version format and all that. So forget that. How can I say that? Okay, unless until you have a binary walker or binary this. But at least something you should understand. What are we looking at? What is the outermost object? Is a hash map. I told you during serialization, it is the state which is converted into binary format, of course, yes. But along with that, there is a class description. The class description means which is the class, whose object it is. So the fully qualified name. Do you remember something called as a load factor associated with the hash map and the threshold capacity? I hope you remember initial capacity and load factor. Then see, again, how can I go through the binary? But I am just giving you the pointers here to appreciate, to understand serialization. This integer is what? A key. But I hope everyone remembers integer is a number. So, when you store the subclass information, the whole superclasses and all that, the information. See, don't misinterpret my statement. Is this binary file containing hashmap.class or what is it? Integer class or product class and all dot class files, the behavior? Of course not. So this is just containing the metadata information, more information about the structure. And finally come to our product class. Is product serializable or not? Now serializable, that is why this whole thing works out. And can you identify the data members, product ID, product price, then the manufacturing date, and the type is the local date, and so many things. So this effort was only, and of course, are we having, last question before the break, seriously last question. So here, are we having a single product in the map or multiple? Answer is multiple. But can you understand this? This is that sequential information keeping serialization. So this information is loaded exactly once, and later all you see is the data. You remember that rice bran oil, sunflower oil, or whatever the details. So the details are kept in the serial manner. So this is what is your first look at serialization. We'll do much more. I mean, we'll do, of course, deserialization and understand much more after the break. So I will just share the code before you asking me for it, in case you want to look at it. So I'll just keep both. The earlier one was written in a by a text format. This one is in the pure binary format. So let's say it as fine, in case you want it. And of course, we are going to resume, and that time you will understand much more. I mean, we'll continue with much more. So take a look at it if you can. Otherwise, we'll go over it and we'll continue with it after after an hour's break. So that will be all. See you around 11. To object. I'm giving you this. So one option is primitive types. Another option is string. Another option is serializable Java object or the collection or all of above. What all you can pass to object output stream? Answer is no. Answer is all of above. See the thing. See, you can pass the primitive type. There are methods from data output. Write int, write boolean, write double. So primitive types are fine. How can you write the string? You can either use write object or you can use write UTF. Can you pass serializable Java objects? Yes, just now you saw that. And can you pass the collection of such things? Answer is yes. Okay, so they are so powerful. Tell me, next question. What is the argument of object output stream? Constructor argument. What is the constructor argument of object output stream? Answer is output stream. So when you say output stream, can I replace it by file output stream, buffered output stream, piped output stream, socket output stream, or any of above? Answer is any of above. Because why? You know the answer. All of them are the subtypes, subclasses of your output stream. So you can pass any of it. So if you want to store that binary stream, serialized binary stream to a file, choose file output stream. Or in other case, if you want to send it to other thread, piped output stream. Or to another remote host, maybe from client to server, you change it to socket output stream and likewise. And then, which is the method which is going to do the serialization? That is your write object method. So answer this. When will write object method throw not serializable java.io.not serializable exception? When it will throw the exception? You know the thing. That is where we are stopped at. So anytime in the graph, the entire graph of object, even if a single node is not implementing, which interface? Java.io.serializable interface. Entire serialization will get aborted and JVM will throw you not serializable exception. I hope people are clear. And okay, so to make this what? The serialization work, which is the interface you have to implement? Java.io.serializable. Is it a marker interface? Is it a functional interface? Or is it standard interface? It's a marker interface containing no methods and no data members. Okay, so this is an empty tag or marker interface. And the moment we made our product class, you can see that serializable. You can immediately check. You can immediately see that the entire serialization simply worked. You got this? Now, if you are keen in observing, I hope you had time, or maybe I just started at like directly 11 o'clock, so you may not have time, but you can observe here. We have seen this warning first time since exception handling. The moment you create a custom exception class, extends from exception, you have seen this warning. I hope you remember. It says the serializable class product does not declare something like static final end. long, basically serial version unique ID. So now you have to understand this. So here, what was the easy way out we were taking so far? We were taking that suppress warnings, but now we will not do that. So here is the time I have to explain the concept behind it. So here, all the things, whatever I want to say, are already written here. So you can directly look for serial version and read this, and I'll definitely explain. Read this much and I'll explain, and then we will add up something. So I'll start explaining. What is the serial version unique ID? It is a universal ID, of course, unique ID for a serializable class. This concept is only applicable to those classes which have implemented serializable. So listen to the questions and answers. Who is going to generate this serial version unique ID and when? Answer is Java compiler uses internally a tool. This is a Java tool. This is not a non-Java tool. So if you open your JDK bin, you will see serial version tool, and it is the Java compiler internally uses it. So listen to the question and the answer again. Who generates this? Answer is serializer. That is Java compiler. When? During the when I say Java compiler, using what? Using the tool called as serial version. Who is going to add this serial version unique ID and into what? The serializer, that is object output stream, is going to add this serial version unique ID for each and every serializable class. Okay, I'll repeat the last few statements again. I did not say. I just add one more statement and repeat the whole thing. How the serial version unique ID is computed? It is computed based upon the class information. It's a unique long number. In a minute, I will generate and show you. So it is computed based upon the class structure, the class description. What all? You can have the data members. You can have the class constructors, which interfaces. In short, in general, the class structure. Okay. So who is going to generate this? Automatically Java compiler. So I can show you using which internal tool, serial version tool, and what? Where it is stamped, where it is added in the binary stream at the time of serialization. In short, when you call write object, your JVM will take this serial version unique ID, which is already present, and it will simply add it into that binary file or in that binary stream. So this is one half. But who uses it and for which purpose? So I've written it somewhere. So can you tell me who is going to use this serial version unique ID? I'll give you options, serializer or deserializer. Who's going to actually use it? Answer is deserializer. So here is my famous analogy. So here again, but I don't know again your background individually. So if you know little bit about TCP, transmission control protocol, a transport layer protocol. Let me, because I really don't know. So at least you should know this because before we meet again for advanced Java, definitely. Coming back. So what is it I was saying? Yeah. Is TCP reliable protocol or unreliable? Tell me. It is a reliable protocol. Whereas UDP, user datagram protocol, is what? It is faster yet unreliable, but unreliable. So the next question, what makes TCP this thing reliable? What is it which brings in the reliability? The answer is ACNOG, ACNAG based protocol. two answers. First is it is a connection oriented. So a virtual connection is established between client and the server. Then the data streams, the request and response data is exchanged, and for every packet, the acknowledgement is sent. Per every packet or per window, whatever, the acknowledgement is sent. So now let me take you. See, this is a good revision anyway. You have to know the TCP. I mean, not to the detail. I'm not saying that you have to understand TCP header bit by bit, but at least overview everyone should have. So what does a TCP sender? What does a sender do? What sender does is, what is the TCP packet structure? You got a TCP header, you got the data bits, and what is there at the end of the TCP packet? Anyone? What is it we add? Not we, TCP. What does TCP add at the end of this? No, packet number and all is there already in the header part. I'm saying towards the end, checksum. Okay, so CRC based checksum, right? So 2 bytes are typically reserved for CRC based checksum. So who is going to compute this checksum and when? Is it a sender or is it a receiver? It is the sender. No. Who is going to compute, I said. So initially a sender computes this checksum, CRC based checksum, whatever the algorithm, we don't care. And those 2 bytes are added at the end of the packet. So who will be sending the data to whom? Sender sends it to receiver. And how does, see, because in between there are hackers, there can be a noisy link which adds the noise. Signal to noise ratio is horrible. So in that case, so receiver, how does it know whether it has got a genuine data or not? Now tell me, what will receiver do? Quickly. Receiver has to confirm whether whatever data packet it has got is a genuine one or the tampered one. How does it do it? What will receiver do? No idea? Or maybe you're taking time in writing. Receiver computes the checksum all over again, and it will come this thing, what is it called? No, not just a parity bit, Mukul, it is much more than that. So it will compute the checksum. Yeah, so SHA and all this cryptography, Akshay, I'm not talking about cryptography, and it will match the what is it called, checksum with the incoming checksum. And if the checksum matches, what will it send? ACK or NACK? I mean, acknowledgement or negative acknowledgement. Of course, a ACK will be sent, otherwise a NACK will be sent. So this part, I'm telling you once again, if the checksum matches Pallav, ACK is sent. If the checksum doesn't match, then the NACK is sent, or there can be a timeout or whatever. So please go through TCP primer, TCP overview. So then in advanced Java, when I start discussing the HTTP protocol, when I say HTTP packet structure, request and response, everything will make sense. Okay, so let us come back on the track. Yeah, otherwise NAC, absolutely. So now extend the same analogy. So tell me, who will compute the, who will stamp, who will add the serial version unique ID? Answer that. Is it a serializer or is it a deserializer? S or DS? It is a serializer. And I've shown you somewhere. If you go to the end of my README, you will see that here, this is written only once, right at the top of the binary stream. And suppose the first class is hash map. Okay, outermost was hash map. So the class description will include the fully qualified class name. You saw that if you remember, java.util.hashmap. And then what sits is the serial version unique ID for every serializable class. So this was computed at the compilation time using that serial version tool, and this gets actually added into the binary stream. And then after that, the description and the state and everything follows. Okay, so this is sent in the serialized binary string. Now, opposite question: who is going to use this information? Of course, okay. Let's have one question at a time. Who is going to use this information? Tell me. Everyone should know the answer by now. Answer is serializer or deserializer. Of course, it is deserializer. Everyone understands that? So deserializer, what it will do? It will check during deserializations. You will have to give those dot class files. All those things I'll cover during the process of deserialization. So here, deserializer will compute the serial version unique ID based upon the classes which it has in the class path, and that serial version unique ID will be matched with, will be to the incoming serial version unique ID. So if it matches perfectly, what does it mean? It means that the classes which it is using for deserialization, the same classes, the same class structure is used during serialization. In short, all is well. And then it proceeds with further steps, reconstructing the object graph. But in case the serial version unique ID does not match, this is during deserialization, which exception JVM will throw? Invalid class exception. There are two triggers for invalid class exception. One is in front of you, other you can read it from the README. So this is what is the checking. Now let us play with it. Let us play with it means what? Let's try to generate it. So earlier we were saying suppress warnings because I never discussed any of it earlier. So now it is very easy. ID gives you ready-made answers. So just click on it. If you have the code in front of you, just click on this yellow bulb as in warning bulb. And here you have so many options. So forget that suppress warning option. Here, when you choose add generated serial version ID, so this option will be done to compiler generated ID. Just check this. And can you see this? So this is the long unique ID, which is based on, which is computed based upon the class structure. Okay. So here, if I just comment this, and if I make this thing, I just want to make a point clear. So here, suppose this is wrong actually. So don't go by it. I just want to make a point. So suppose I say all products are manufactured in the same date, on the same date. Okay, I'm not adding static initializer block and all that. Just keep watching, guys. So here I commented this. Let me generate the serial version unique ID again. And tell me, is it the, okay, forget. Okay, I'll ask you. Intermediate question I was not going to ask you. Is it the same serial version unique ID or different? Simple question, simple answer. Of course, different. So why I'm doing this exercise? Just to confirm with you the fact that the serial version unique ID is generated by the compiler using that serial version tool based on the structure of the class. Are we understanding it? Are we getting this? And of course, we will see it during the deserialization. Okay. Once again, I'll show you when I take you to transient and all that. So coming back to the point, I of course don't want to make it static. And it will be changed. I mean, it will be computed again. This is nothing but the computed one. Okay. So now a small other statement. So which you can see there is no, I can remove all of that and generate it in a second. So that we have made it. Yeah, I made it this fine. And I say generated one. So this is a long unique number as you can see. But if you actually go by the standards or the norms, what people suggest is don't use the generated serial version unique ID, because if you change the Java versions, or I'm using Oracle JDK. Suppose you are using OpenJDK or Corneto, which is your AWS one given. Different JDKs. The moment you have the different compiler, the serial version unique ID can change. And even when, listen to the statement, I don't know how much it is reaching you. So read the docs properly. Docs in the sense, my readme properly later. So what is typically suggested is, this was only done to tell you that it is definitely dependent upon the class structure. But while actually putting it in the production and all that, we don't use this option. Can you see the other option? The other option is default serial version unique ID, so that it is generated irrespective of the JDK or irrespective of the compiler you are using. And unnecessarily, during deserializations, you will not get a invalid class exception. So this is what I just wanted to, this is a famous question, popular question, and definitely read it later using, I have given in details also, what is happening when each time object is serialized, the ID and all that. It's this. And I have also given you what is it which will change your serial version unique ID, what changes, and what if you suppose add a new field, if you add a new class, nested classes or whatever, that won't affect the serial version unique ID. So the keep the bottom line clear. The bottom line is the deserializer will actually use this particular serial version unique ID number to confirm whatever classes it has from the class path, is it having the same version of the class whichever were used during serialization. So this is the final recommendation, but I'm going to keep it under comment because again, we might want to play with it. So what is the recommendation? Should you use the generated serial version unique ID or should you use the default one? This is the recommendation. Recommended is this because then it will be independent of the compiler, independent of the JDK, whichever you are using. So that is a standard norm. But like I said, I have some other points in mind. So I'm just using this one. I have the transient and all I want to show you. So this is the one. Okay, so this was the initial part. What we have finished so far is only the serialization. Let us proceed to deserialization now. So you have seen it. We have got our this also. What is it we have? Wait a second. Yeah. So we have got our binary file created. So now what is the objective? Whatever you are storing, of course you have to restore. So the objective is restore, reconstruct Java object from a binary file. So the first thing is what should exist as a prerequisite? The binary file. So this was an employee scenario, doesn't matter. So employees.scr, customers scr, products scr, anything. So this is your binary file and you want, without taking any, you as a programmer, you don't want to take any efforts. You want the Java APIs to do this reverse construction, restoration. So what is it we want? Listen to this. What is it we want very carefully? Here we have added entire hash map. You remember out.write object hash map. So this is containing the entire object graph starting from hash map, its key value pair, product has a enum, product has a category, etc. So now all I have got is couple of bits. Binary file is what? It's a long binary byte array. So all I've got is the zeros and ones. And what is our expectation from the deserializer is when we perform the deserialization, the entire hash map object. Are you understanding? The entire hash map object should be reconstructed in which memory area naturally? Stack, heap, or method area? Of course, heap. But for object creation, classes have to be loaded. So all those classes should be loaded automatically. And the reconstructed hash map containing the state which is stored in this binary file should be reconstituted, or I mean reconstructed. That tall demand we have from the JVM. So now look at this step by step. So everyone knows, if I want to read the binary file, when you have four options, file input stream, file output stream, file reader, file writer, what is it you'll use naturally? File input stream. Everyone understands it? I have not drawn. Okay, I have drawn only the arrow here. Please add the arrows here. We are reading the data. But if you drop this, if you don't add this converter stream, can I connect file input stream directly? Can I read the file input stream directly? Of course, yes. But then who will have to do the tedious conversion from byte to object? A programmer. Instead, enter deserializer. So what is it? You have a object input stream. And the moment you see input stream, what it tells you is it can read the binary stream from a file, socket input stream as in socket, piped input stream as a pipe, or console input, wherever, anywhere it is getting a binary data, it doesn't care. All it requires is the binary input stream. So as usual, is file input stream or input stream? Answer is yes. So I can definitely attach. And when you see object input stream, this is where the, like how object output stream was acting like a serializer, object input stream is the one who is going to perform the deserialization. So this is nothing but referred to as deserializer. And which are the two interfaces it implements? Data input. So thanks to data input, you got variety of methods, primitive type methods, read int, read byte, read char, read long, etc. Read UTF and all. And thanks to this object input interface, you got one method, multiple methods, important one only. So here you have got all these are the data, primitive data methods, plus you have got read object. And when you say read object, it includes in the throws class your, what is it called? IO exception, if something goes wrong in reading the data. It includes in the throws class not found exception. I'll come to that point in a minute. And it also includes in the throws class, just now I mentioned an exception. Which exception? If the serial version unique ID mismatches? Invalid class exception. Okay, so these are the throws class details. Now, read this, and already I have ticked the correct option. What exactly gets serialized and later deserialized? Is it a state? Is it a behavior? Is it a both, or is it neither? Everyone knows it is only state consisting of something non-static, non-transient data members. But now apply your Java sense, which we have given you, I hope, from the second day onwards. Anytime you say, I'm creating a scanner instance, I'm creating a product instance, I'm creating an employee instance, before instantiation, what has to happen in the method area? Everyone knows the answer. The object creation has to be preceded by what? A class loading. Are you understanding that? So now let me ask you a question. In this binary file, in this binary stream, is there a dot class information? Are there the compiled dot classes stored in this binary stream? It's a yes or no question. I'm saying the behavior part, the dot class files, byte codes, are they the part of binary stream? Of course not. So, a popular question. What is that popular question? What are the prerequisites? What are the requirements before your deserializer can perform the conversion? So answer is, how many inputs it will require? Answer is 2 inputs it will require. So which are those 2 inputs? One is the state. The state is all coming from that binary file. And what is that other prerequisite you'll require? You will need to supply the byte codes. Byte codes means what? Dot class files. So dot class files of, let me take a precise question, because this is a very important point. So tell me, wait a second. So do I have to provide the dot class file of hash map, integer, product, all of above, none of above? So, okay, people are saying all of above. That is required. I'm saying as a programmer, what is it you'll have to provide? See, we are writing a Java application. So what are these? These are the Java built-in classes. So, okay, let me phrase the question properly. What is additional information I'll have to supply is the user-defined types. Okay, so if you have got a product, you will have to ensure that all these additional classes which you are using, which are going to be required for deserialization, you will have to provide them. So if it is just a one class, what will you do? What can we do? We can simply create a copy. We can create a compiled output product.class and just supply it, just give it to the deserializer. But if suppose there are 10 dependencies, I've got a product, I've got a customer, whoever is purchasing that product, I've got a customer address, I've got product line details, and suppose 10 classes are there. So tell me, which will be better approach? Should I share these classes as a separate dot class file, or should I bundle it? Should I bundle it together or separate? Of course, bundling is the correct option. And what is the Java type? What is the Java archival type? Everyone knows. Which is the file format? jar file format. Not JAD. JAD is for Java application decompiler. jar, Java archival format. So you can create a bundle of classes, and then you can provide it to the deserializer. So coming back to the point here, I've not written. Okay, so I'll have to say verbally. I've written it in I thought I've written it in the diagram also. Anyway, doesn't matter here. So let me just take you. What are the, wait a second. Somewhere I've written the prerequisites and all that. Have I not? Otherwise, I'll mention. I'm sure I've written. Just give me a minute. Yeah. So here, what are the essential things? What are the prerequisites during the deserialization? Of course, you have to supply the bytecodes. That is dot class files for the entire object graph to be reconstructed. So like you told me earlier, all. But I'm saying you actually don't have to provide the Java built-in classes. They're already. When you have JDK, JDK has a JRE and Java tools. So JRE already has the libraries. So that is already there. So only the user-defined types you should supply. And you should have a binary data stream containing the state. So as a exercise, I do this exercise generally. I mean, always with the beginners. So see this. Which of the part is done? Have we completed so far serialization or deserialization or both? S or DS? Only the serialization. So now, if you are working along, I should have actually told you, I forgot to mention in the break. The whole day is going to be like, lecture lab kind of a thing. But anyway, doesn't matter. So if you can, because I forgot to mention, make a copy. I have shared this code. So make a copy into another one. Or okay, forget it. Wait. Let me, I had a better thought. Don't make a copy. Let's create a separate project. One for serialization, one for deserialization, so that I can show you whatever I've been saying is correct and not wrong. So if you want, please work with me parallelly. If you can, of course. And let's be 16.3. And here we will simply write the deserialization part. See, actually, in the practical cases, practical scenarios, you would be performing a serialization on the client side machine, which could be 100 miles or whatever miles across from your server. And you will be sending the data using that binary streams over socket, and it will reach the server. And the server side code, server side Java code, you will have to do the reverse conversion deserialization. But since we are not having two different machines, I mean, you don't have the networking at this in core Java. So what I'm doing is at least I'm splitting it into two different projects to give you a feel of real stuff. Coming back. So what is it we are going to do in day 16.3? Serialization, deserialization, both or neither. Let's have the concept clear. Only deserialization. Absolutely correct. So let me not waste time. So here I'm saying I'm creating a utils package. IO utils. Oh, sorry. I wanted to make it as an interface. My mistake. I, I mean, out of habit. So here, because it's just going to have a single static method, utils. And what is that name? IO utils. Actually, I could say deserialization utils and all that. And now, this is where you are going to pitch in. Add a static method. For what? For reconstructing or restoring. The hash map in Java heap from binary string. Okay, so let's add that. Sorry, public I don't require since I'm in this interface. Static. Now tell me, this is a method which is restoring. So what should be the return type? Void or not void? Quickly. Should it be void or should it be not void? This is how you are going to design your APIs. So better be clear, non-void. And naturally what it should be, of course you are right, non-void, but what it should be? Yes, please. It's a map. Absolutely correct. But I have, because what you have stored is a map. So you are going to restore it as a hash map. But I have a point to convince you. So let me skip that. Map is an object. So I can restore it as an object and then downcast and all that. So object, and let's say restore. I have a small point there. Later we will change it to map. Don't worry. So whatever. Restore product details. And the only thing, what is the only thing you will require here? The name of the file from where the binary stream is. So name is something, file name. Okay. Now identify the chain. Java app. You're going to read the data this time. So which is the deserializer stream we have? Object input stream. What is it you are going to connect it to? Where you are going to read that binary stream from? File. So what does represent the this thing? Binary input stream for file input stream, and that is going to wrap your binary file which we have created earlier. So before I forget and before I start getting file not found exception, can you tell me what is it I'll have to copy from day 16 from the serializer to deserializer? What needs to be copied? I hope your answer is clear. Products.scr. What else? The data file has to be, see, currently I'm running it on the same machine. Otherwise, you can FTP, you can share, you can do whatever, you can send it with whatever mechanism. Later with web server, we'll do that. So just check this. I have got a products.scr copied as in front of you. And now, so this is what does the job. So let's have in a minute this comment translated. So which is the class I should instantiate? Which is the deserializer object input stream? New object input stream. And what is it is going to read from? What is it is going to read? What will be the argument of the object input stream? File input stream. Yes, Akash, you're right. So here we'll have new file input stream. This is your binary input stream, and you can supply either something called as a file class instance, or you can simply supply a file name. Okay. Naturally, if there is a problem, if the file is not found or you don't have read permission, it includes in the throws class file not found. And the one which you will require for reading is the IO exception. So I'll just make throws IO exception and satisfy the compiler. Now I'm going to write a one-liner. So I will start it for you. Somebody needs to complete it for me. What should I return? One-liner. I hope you remember the earlier one. So anyone wants to write here. What should I mention here? Which is the method which will actually do the deserialization? You know the answer. Absolutely correct. In dot read object. Okay. So done this. It is saying unhandled exception of the class not found. So currently, don't worry. Don't worry as in what? Ignore this, why it is saying and all. I said it earlier, but I need to convince you people. So this is a compiler was saying that it may throw class not found exception. I don't want to handle it here, so I just include it in the throws class. Next one. So now let me write a one-liner tester. So 16.3 SRC. Without all this, you don't really appreciate, you don't really understand what is happening internally that way. So what is it here? Test deserialization, or I can say restore products, something. And you know your import static. This. All this is done. Again, there I have said throws. So this is the best place to do the centralized error handling. Catch all and all that. And here all I'll require is the scanner. Because IO utils part I have taken care in the separate class, separate layer. Okay, so this is it. And all I will ask user is enter the file name for restoring, for deserialization. And now who has to call whose method? Tester has to call the IOUtils method, which is the name I'm just looking for. Yeah, I got the name from there, restore product details, restore product details. And here you can use next line. All I'm using your next line suddenly because your path, if your file is in some other folder and if it contains white spaces and all, otherwise it won't work. And to keep it light and simple, clear, I'm just putting it through the SOP because our point is something else, not really immediately this. And here I'm saying the deserialization over. Okay, so listen to this carefully. If everything goes well as per expected, as per expectation, what is the compile time type? You know compile time type and the runtime type also. So can anyone tell me what is the compile time type of this return? Compile time data type, object, absolutely correct. But what is the runtime data type you expect to see? It's a map. Everyone understands it. And you know, we have spent so much time in runtime polymorphism. So when you say SOP using println, everyone knows toString will be called. So whose toString will be called? Object class's toString or the map's toString? O or M? Of course it is overriding. I hope nobody is saying object. Oh my God. We have to rewind all the way to the second, third, fourth day when we said this JVM goes by the type of the object and all that. Come on, guys. This is really shocking. I'll just excuse you by saying maybe too much of web technologies, but otherwise there cannot be any other excuse. I'll repeat the statement. This was really a shocker to me. I said, or rather, you also told me correctly, so I don't know why you goofed up last minute. You said that runtime type, what it is actually going to return is a map. So when you say SOP, whose toString it will call? The object class, the object type of a reference is pointing to the hash map or tree map or whatever we had, hash map, I guess. So whose toString you expect to see is naturally the runtime type. So the hash map or whatever maps toString is the answer. Okay, so don't mix up at such a basic level. So coming back to the point, when I run this, you're not going to get any compile time error. You can see that there's no compile time error, but there is going to be a runtime error. Anyone wants to guess? You're not going to see this output. So which runtime error are we expecting? The class not found exception. So that is what gives the confirmation to the statement which I made earlier. Are you understanding what is going on or are you thoroughly lost? I've got two separate projects. Which two separate projects? One for serializer, one for deserialization. So if you look at my package explorer, see this. See, I'll close this. What is it I'm having here? I'm having a tester, which is what I wrote just now. I'm having a IOUtils, which does the deserialization, and all I have got is the binary stream. So tell me, what is it we are having here? Are we having the state, behavior, both or neither? What is it we are supplying to the deserializer is only the state and see the outcome in front of you. That is why I take so much efforts. I took so much efforts rather. So here, just check this. So it is in the same folder, so I don't have to give any path and all. Products.ser, and as already guessed, see, it is giving you class not found exception, but it is not cribbing for your hash map and integer and all that because those are Java built-in classes. So anytime you are having a Java application, you have a JDK. Forget JDK, you have a JRE, and that has that all those library classes. But this should be a POC, proof of concept, that unless and until you supply the bytecodes, the dot class files of your UDTs, how can JVM reconstruct the object graph? Means what? In a simple English, you know, think like JVM. So what it does, give me a second here. When you say in.read object, which is the file it will start opening? Answer that. Which is the file it will try to open? Your products.acr. So let us be the JVM. I mean, kind of JVM. It's too much. So now it says which is the first class? Java.util.hashmap. Tell me quickly. Can it load this hashmap class in the method area? Of course, yes. It is a Java built-in class. Goes ahead. Integer can be loaded, number can be loaded, and when it comes to this one, now it says before it can reconstruct products object, what has to be loaded in the method area first? Naturally, the product class. Checks into the runtime class path, doesn't find it, throws you out, saying class not found exception. Are we understanding it? Are we clear what is happening? So this is what I meant. What are the two prerequisites of deserialization? The two prerequisites of deserializations are the state, the binary, the object state, not ID, the whole state, complete state, which you supply via binary file, plus the dot class files, the byte codes should be available in the runtime class path. So which are the two prerequisites? The dependencies, the user-defined types.class files plus the state. And which one I have only supplied is the state. So now, how is the, I mean, how do I get rid of this? How do I get rid of this exception? I have to supply. Which file has to be supplied? Tell me, give me the answer. Which file I have to make it available to this project? Yeah, dot class file, but which dot class file? Okay, right. Yeah, maybe there was a delay. I was not getting any responses. Product class. You are partially correct. Okay. So suppose I'm not doing it because it takes too much and we are getting late in starting threads. So coming back to the point here, let me say, suppose I copy this product class. I'm saying again, you will have a class not found exception. Anyone tells me for which class? I said, I'll repeat it slowly. The answer is right in front of you. Even after supplying the product class, you will still, in the code will still fail. For which one? Which one? No. Serial ID is this one, Roshni. If you don't actually add the serial version unique ID, this thing, it will compute. The compiler will compute. So your answer is wrong. Yes, Surya is right. So here, product has a category. So is category the Java built-in class or our own, I mean, enum? It is our own enum. So all the dependencies must be shared. Otherwise, 100% class not found is class not found exception is guaranteed. So now tell me. So see, there are only, this is such a small example, tiny example. So I have only 2 dependencies. What if I have 50 dependencies? Which one is a better approach? Share them separately or bundle it in a jar file? Everyone knows the answer. So that is what my intention was. So I get a chance to show you. We are almost towards the end of core Java. So I have to show you how do you distribute your core Java application. In such cases, answer is by creating a jar. So there are 2 different types of jar. One is a runnable jar, one is a non-runnable jar. So today what I'm showing you is the example of not runnable, not executable jar. In short, it does not have any class having the main method. There's no execution point. Because all I want to share is the dependencies between the serializer and a deserializer. Some other time we'll take out time. I'll tell you exactly when. So first thing in your advanced Java is still a project. It is a topic called a JDBC, Java Database Connectivity. Wait a second, Akash. I'm in the middle of the statement. You think about your own statement here. So in JDBC, we will write an end-to-end application, and that time we can combine things like this. Ask yourself, Akash, now I'm coming to you. Enum class has not to be supplied, but category is not a Java built-in class. So you'll have to explicitly add that dot class file. I never said enum has to be supplied. I said category class has to be supplied. Okay, so let us, fast forward is not this. Let us move on. So what should how do I create a jar? If you open JDK bin folder, there is a jar tool. The jar tool means there is a jar command line option, and then there is a option CVF. C for create, V for verbose, and F for file name. And then there is a concept of a manifest file and all that. But since we are anyway in the ID it is everything on the right click. So check what I'm doing. If you want, if you are logged in already, you can do it parallelly with me. So here, tell me, this is our serializer project. What has to be shared with the deserializer? I'll ask you. Core classes, tester, utils, all of above, none of above. What is it I need to share is only the core classes. That is why I always insist that separate it in the separate packages. So right click on this, and here can you see the option you know about importing. So now we are exporting these classes as a bundled output. So use the export option. Right click on COMAP core, say export, open expand that, and under Java, this is that general option for importing projects. Here I want to export it as a Java file. Later, aspect J and all later. So here there is a jar file and there is a runnable jar file. We are not having a runnable jar file since none of these classes contain the main method. So choose jar file. It's a easy one. It's all wizard driven. Here you can check this. So if you expand, it has picked up only your selected project. I mean selected package, I should say. And it says export generated class files and resources and all that is fine. And it is asking you what should be the name of the jar file. So you can, if you're working on Mac and all, you can give as per your folder structure. I'm saying here D colon whatever. I'll say, what is it? Product related. So I'll say, I'm just calling it something, product dependencies dot jar. The extension has to be dot jar. When I take you to web programming, we will replace Java archival format to a WAR file, web application archive, and then we can deploy that WAR file on a web server. So in core Java, the distributable bundled output is a jar. In web application programming, it will be a WAR file. So jar file is here. This is fine. Compress the contents and all is fine. So next step. Here, it is telling you how do you want it. So of course, I don't want to export the class files with compiler errors. Warnings are fine. Sometimes I may ignore the warnings. So change it accordingly. And you can simply say finish. It is nothing but using internally jar cvf command. So now you should check from your folder structure. D drive. What is it? I said product. So there is a product dependencies. Yeah. So can you see this? This is that executable jar file. I mean, it says executable jar file. It doesn't have a main method. If you have a WinZip, WinZip, you can open that. Or okay, what I'll do is I'll do a better job than this. Of course you can open it, but you can open it with your jar tool also. So observe what I'm doing. Okay, let me open the command prompt from here. I did not show you the creation of jar. Let me at least show you the contents of the jar using jar tool. So on the first day of Java, I have asked you to put in the path, the first entry as JDK11 bin. So in short, everyone's path is set. So now I'm saying jar. Do I want to create the jar file or just display the contents of it? Creation is already done. So display. So T for tabulate. V for verbose. Verbose means it will tell you what all it is happening. F for file name. And it was something like product dependencies. Yeah. Product dependencies.jar. So you can actually see, So other than this manifest file, can you observe, can you relate to this? This is your fully qualified class name. So com app core product and com app core category. But you will of course want to know what is that manifest MF file. It is nothing but when I import it, I'll show you. So currently it is going to be the empty file, just having some Java version related stuff. When I show you the example of runnable jar, runnable means you can run it using Java, jar, and file name. And that time I'll show you that jar, that manifest file will contain the name of the main file, the name of the class containing the main. So all those things at proper time. So now let me ask you what all we have done so far. We have written the serializer, deserializer, deserialization field. Why? Because there were classes, there were dependencies which were missing. So tell me, have we created the bundle of dependency classes? Is it a yes or no? Answer is yes. So which is the only step which is missing? I have to ensure, I have to give those dependencies, I have to share those dependencies with my deserializer. Okay. In short, in simple words, what is it I'm saying is, I'm just showing you how to add this jar file into the class path. Okay. So here, how do we do this? If you want me to repeat, I can always repeat it in 10 minutes in the lab, not more than 10 minutes though. So right click on 16.3. Can you see the entry build path? Right click. This is the same process we will follow when I take you to JDBC and we add the JDBC driver, JDBC connector. MySQL basically will have the database connector. So similar steps will be. Only thing is that JDBC driver will be MySQL supplied. Here, this is the jar file which we have created and adding it in the class path. So anyway, right click on the project, build path. Last entry is configure build path. We are not using the, what do you say, module path and all that. We are using the class path. So click on the module JPMS. The module system and all was introduced 9 onwards. We are not using module path. So click on class path. And can you see your buttons? So one of them is add external jars. So this is where it allows you to add. Add means doesn't copy. It will simply add the entry of the jar in the runtime class path. So where is my jar? My jar is in the this whatever products jar. So product dependency jar, and I say open. So here I'm adding under not module path. Module path, you have to build a module. Module is a set of packages together. So we are not getting into modules here. We're simply having a jar file, having the class put in the class path, apply and close. Now notice some things. This is very good to be done in a parallel manner when you have computers in front of you. So if you focus on package explorer, I'll get it done in 10 kind of 10-15 minutes. So here you can see there is a JRE system library which is already there, Java system library, I mean JRE. And can you see there is an additional reference library. When you expand that, what is it we have added? This is your first time I'm showing you. Wait for Spring Hibernate and you will have tons of jars, added in that, minimum 30 to 40 jars like this, so we will expand. Now you click on that, you expand on that. And this is what I wanted to explain. So I showed you from jar tvf command prompt and all. So this is your pack. These are your package classes. All the dependencies I have shared fine. And I wanted to show you that manifest file. So what is the signature document, which is the which is the signature folder of a jar file? It is meta information folder, meta inf. And which is the one file which will be always there is manifest file. And manifest file, as I told you already, this is not a runnable jar. This doesn't have any main class and all. So all it adds is the version. When I take on someday the example of a runnable jar, it's just with JDBC and all, any this I can show you. So then it will contain the name main class and the name of the main class, name of the class containing main, all that. So I hope you have got some steps or some idea about creating the jar. Yes, exactly. Manifest JSON. Exactly. So here you have package JSON. So you have package.json file, you have manifest.json. Here it is manifest.mf file for telling you the details about the jar file. Coming back to the point. Now let us run this code as it is. So tell me, what do you expect to see this time? Class not found exception or no exception? Runtime error or no error? So, of course, The answer is no runtime error. I can show you the invalid class exception error also, but that is a lab kind of activity. So we'll do it in the lab. In short, take a look at it. I'll just put it in a text editor and you can see that just with one line, can you appreciate this? With one line of in.read object, entire hash map containing all the product details, product having local date, manufacturing date, price, categories, etc., is completely restored. So this is about your serialization and deserialization. And now you'll understand, I mean, why I did it in two projects and all that. So to give it as a, to give it as a proper closure, here in this, I'll just slightly modify this because I'm going to give you two assignments. I mean, we'll start with the threads in next 5 minutes. So one will be, of course, thread-based something. But before that, I have to give everyone has to work on one serialization, deserialization one. So we will combine serialization, deserialization with collection, and you will give me one end-to-end solution. So that we will discuss. If we give the class files to the client, then we are exporting. No, this one, Surya, unless until they have decompilers, you can't do that. And when I tell you about the disadvantages of serialization, deserialization, yes, there is a security hole. Security concern is, of course, there. That way. So coming back to the point, let me now, the earlier stuff was done because I wanted to show you things. But what is it I'm really restoring is map. What is the type of map? Integer, comma, product. And here, now tell me, is a map or object? Hash map or object? Yes, but object is not a map. So you'll have to supply the downcasting. You can just see map here. And here you will see that warning, map is a raw type and should be parameterized. So I'm just showing you warning and removing it one by one. So you do this. And then you have another warning that this returns you an object which is a raw type, and what you are using is a generic type. So since here we know what we have added is actually a map of this type, you can ask the compiler to suppress this type of warning. Serial version unique ID we are not suppressing. We are just suppressing the unchecked warning, which tells the compiler to go ahead with the conversion from raw non-generic type object to a generic type, since we have written the serialization part. And then you have I written it properly? Yes. So then, see, earlier it was an object, so I could not use any of our streams API and all that. So now I can do better. So I'll just write it in one line, you know everything. That's just a functional programming API I'm using. Can I attach a for each to the map? Yes. From Java onwards, it is possible. What is the functional interface it takes? The by consumer. By consumer means two arguments, k comma v. I'm interested in product details because product details does contain my product ID. So you know all these statements basically. So that I don't have to see it in those curly braces. Hash map output, hash map toString. I can put it on different lines and get the job done. So output is going to be the same naturally in a well formatted manner. So what was that? Products. And you have the sample data. I mean, we have hard coded the sample data. So you can definitely compare and you will see the entire hash map retrieved with a deserialization. So this is what I wanted to show you. And like I said, I have taken a very simple example which doesn't have too much of collection. So while you are preparing, whenever you are preparing for Java Lab exam, core Java Lab exam, definitely expect the integration of at least one or two topics. So the famous integration typically we ask you is collection and IO. So majority part will be collection, but somewhere to give the persistence to your data, you'll be definitely, I mean, definitely is too much, but okay, you can be asked the storing part, restoring part, so that we can check whether you have understood the topics which we have discussed. Okay, so that is what I wanted to discuss. Without wasting a single minute, let's enter threads. So you will have a proper assignment, which I will get it done. All batches are together today, 3 to 6. I hope you have taken a look at your this thing timings. So so you will definitely, of course, join in time. I'm not guaranteeing that the starting time I'm guaranteeing 3 o'clock, ending time I'm not guaranteeing. So you know what I mean. So coming back to the point, we will definitely ensure that you write in with proper speed, not too much of a delay. A full example which has serialization, deserialization, and then I will also get done something. It is going to be a combined session. So little bit of theory, whatever I can't cover, I can barely start with the threads here, looking at time. So I'll continue with the theoretical part and we'll discuss the assignments as well. So it will be a combined session. So now be mentally prepared. That's why so many statements. And I'm telling you, it will be. Yes, absolutely. And if you allow, I mean, it's not allowing, I know it's not that, but if you allow me, the majority of advanced Java also I want to handle it in this manner. I'm telling you, you can experience it and you can always tell me. But I've seen it in through so many years. If you are doing it, some part, not the concept heavy part. Concept heavy part has to be understood first. But for example, there's something called as life cycle of web components and all. That's a concept heavy topic. So at that time, I'll never tell you that, okay, do some programming with me. But there are certain hands-on steps. If you do it parallelly with me, the clarity definitely increases. Anyway, you can be the judge of that. So let me start. Let me take you to, let us start with the threads. And again, sometime I have to, I can't directly jump to the asynchronous programming part. I need to give you some background. And of course, I'll be giving you that background. So if you see today's help, so you'll see a different this. And I'll tell you over the time what all are the important readmes and all that. So first thing first, okay. So start with why multi-threading. Not even why multi-threading. It's before that, why multitasking. So read this slide and I'll start explaining. And again, I don't want to disturb you, but one more announcement. Swati ma'am, I don't know whether she has yet informed you or not. Definitely you can't finish the threads. So I'm going to request you to come on a Sunday because now tomorrow your other module has to start. Has she informed you about that? Yeah, Sunday session. Okay, okay. So then I don't have to say anything. Let me not waste our time. So happy Sunday in advance. So coming back to the point, start. I'm talking about multitasking. I'm not even come to your thread level or process level because I'm dealing with a mixed crowd. Some of you already must be having complete idea of OS concepts, operating system concepts. Some of you may not have. So, let us start on the common background. So why multitasking? If you see any of today's operating system, they are multitasking based. So simple question, simple answer. To increase the throughput, to increase the effective utilization of your processor having multi-cores, plus effective utilization of your resources. So which resources I'm talking about? It could be a disk, it could be any device. It could be, it could be, yeah, any, like for example, files. It could be your database. It could be socket, any resource. You don't want to have the inefficient, you don't want that resource being underutilized. So what we mean by that is, since there can be so many tasks which are running on your operating system, here if one part, one task gets blocked, because that task is waiting for the acknowledgement from the server, for waiting for some response from the server. All other tasks, one of the tasks could be doing the UI, user input. One of the tasks could be playing a movie clip, or audio, or whatever, I mean, or some spell check or anything. So all those other tasks should not get affected. So to ensure that one of the blocking tasks does not affect other runnable tasks, other tasks which can run, which can execute. So that is the gist of why multitasking. So when you know about multitasking, when you can visualize the multiple tasks getting executed concurrently, parallelly, this multitasking can be achieved at a process level or at a thread level. We are of course doing thread level. This is just a background. So when you talk about process level multitasking, what is it which will manage the multitasking, be it a thread level or be it a process level, is the operating system native scheduler. So you have multiple tasks, and let us say you got just one processor. You have multiple processor having multiple cores. Let's say single processor you have. So it is the scheduler which will choose the highest priority task, and that will be given the time to that will be given the CPU time for execution. So coming back to the point, when you go for process level multitasking, the unit which gets swapped in, which gets CPU time, and the other unit which gets swapped out is the entire process. Can a process-based multitasking be controlled by your Java technology, as in JRE or JVM? Answer is no. Why the answer is no? Because JVM itself, when you say Java test, JVM itself is a process which is running on the top of your operating system. So how can it control other multitasking, unless until you enter something called as native JNI, Java native interface? We are not doing that. So this cannot be controlled by Java at all. And the third thing is, there is a term called as context switching. What is the meaning of context switching? Context switching is swapping one task out and bringing in another task to execute it with the CPU time. So when I say context switching is heavyweight, these are the typical terms you hear. That is, it is time consuming. Why? Because simple question, simple answer again. Different processes, do they share the address space or do they run in separate address space? Share or separate? Answer is separate address space. So when you are swapping out one particular process, you have to save the entire environment. Context is nothing but the environment. So all those data, whatever data, everything you have to take it and you have to push it on the RAM. Okay. Or sometimes if the RAM is kind of full, you have to put it on the disk. Okay. So the point is, the context switching is time consuming, because when you want to restore, see, currently I'm showing you something like a photo viewer, image viewer. So if I swap it and open the Eclipse ID, this is what? Context switching. This is one process was on the background. Now I'm putting it in the foreground. So lot of information has to be saved and restored. So the point I'm trying to make is, these are the features of process level multitasking. But the point is, can one single process, can it be divided into parallel, asynchronous, concurrent running tasks? It's a yes or no question. Answer is yes. Not always, not 100%. Sometimes, it requires the sequential execution. But if you can identify, if you can split up your process as in Java application, I'm talking in Java naturally. If I can identify the parallel concurrent runnable tasks, each of this can be represented as separate flow of control. Till now, you have a single sequential execution of control, which is your main method. Main thread was calling the main method sequentially. Are you remember? I mean, you understand that. So now I can take that and divide it into multiple parallel tasks. And these parallel concurrent runnable tasks individually can be represented by a parallel asynchronous flow of control. In JavaScript, we have async, await, and all those things, right? So when you say async, what is it you are starting is an asynchronous task, which is not going to get executed immediately, but at a later time. It could be set time or it could be anything. So the point is that is what is your threads. And when you do the thread-based multitasking, which is what we are starting in a minute, can JVM control it? Answer is not fully, because ultimately, who is going to control this multitasking, whether it is a process-based or thread-based? Native operating system. Which part of the native operating system? Scheduler. So here, of course, it will be done ultimately by the native scheduler, but getting those threads, taking it from the programmer and, giving it to the underlying operating system. And I'll tell you, when I take you to state transition, I'll tell you that this is what is done by the JVM internally. So keep it superficial light just now. It can be controlled partially. Some transitions can be controlled, some cannot. And the main thing is the context switching is extremely light as in fast, because on the first or second day, you remember we had drawn the memory pictures. I mean, sorry, memory areas I meant. So tell me, if you talk about heap and a method area, how many copies of heap and method area we make? Is it one copy per thread or one single copy shared across the thread? One single copy shared across the threads. Which is the only copy which is created per thread is your stacks. Everyone knows that. So that is what the multiple threads coming from the same Java application, will they share the common address space? 100% yes. So whenever you have to do, you means your scheduler has to do the context switching, very less information has to be saved and the restored. So from now this point onwards, we are going to deal with thread-based multitasking. So this is what we are starting with. The next background, again, I'm sure, I mean, most of you must be having it, but again, no assumptions. So you have to keep in front of you a thread state transition diagram. So generally I ask people to draw it and all, but looking at time and in general things, you don't have to draw it. But I'll be, I mean, we are approaching a lunch break sometime later. So you keep it after when we have the common session, lecture lab session, keep this in front of you and you can write multi-thread applications so easily. So let me start explaining. What we are looking at is a thread state transitions. This is applicable to any technology. Only thing is some words, some APIs which I'm using, for example, sleep, there is a wait, there is join, there's notify and all that. Those are Java specific APIs, but overall thread state transition is the same, independent of technology. It is managed by operating system. Anyway, so let me not get distracted. So when I say thread state transitions, whether it is a main thread, garbage collector as in system threads, or user defined threads, which we will create, programmer created threads, same life cycle is followed. So start. I'm just checking, is there a question here? No. Okay, so what does everything start with is thread does not exist. So the first thing which when I say thread does not exist, I mean our threads, our means user defined threads are not yet created. Threads do not exist. So in Java, what are the three different ways in which you can create a new thread? So there are three different scenarios or three different techniques. The first two I'll be taking now as in today, tomorrow means Sunday. But the third one, which is the real efficient one, I'll discuss it with web server, web container, because they use the same. Anyway, understand the point. So first one is extends thread scenario. That is, there is a java.lang package everyone knows. There is a thread class which represents a separate flow of control. So, is a relationship. If I write, think in code, public class, my thread extends thread. Tell me, is my thread a thread? Or rephrase, my thread is a thread, true or false? Of course, true. So that is how you can inherit the thread behavior. But if your class, if your user defined class, suppose it is already extending from some other class, you cannot extend from multiple classes. So what is the solution? Here in 99% of the cases we are going to use is, we will implement the interface. And what is that interface? It is a runnable interface. Runnable interface is the heart, is the starting point of multi-threading in Java. Later, when you go to advanced things, you will see there is a runnable, there is a callable, there is a future, there is a, like your promise in JavaScript. Here we have future. In short, there is a lot. So this runnable interface, is it a what? Is it a marker interface, or is it a functional interface, or is it an ordinary interface? Answer is, it is a functional interface. The moment I say it is a functional interface, what should be your next question? Which is that single abstract method? Answer is run, public void run. So I'll show you. See, I don't do it in this manner, like go completely theoretical. So let me open a whiteboard here so that parallelly. Otherwise, if you keep hearing about the states and all, slowly it gets slowly, or I mean anytime it gets boring. So here is the parallel API picture. So here what I'm saying is multi-threading API. So I'm just trying to balance between a concept and an API. So what is the starting point here? The starting point of multi-threading API is beginning point or whatever, is nothing but the interface. Which is the interface we are talking about? Runnable. Is it a functional interface? Yes, it is containing a single abstract method. And what is that single abstract method? It is public void run. And you will see that whether you are going via extends thread scenario, or whether you are going by implements runnable scenario, or later executor framework, the basic step is the same. The business logic, the thread execution logic, whenever a thread gets a chance to use the CPU time, who should supply the thread execution logic? Choices are programmer or your JVM, I mean Java technology or operating system. Who should provide the business logic or the execution logic? It's a simple question, simple answer. Of course, us programmer. How can Java or your operating system understand that whether you want to read the data from client and send the response, or do you want to read some data sample from database or whatever? So this has to be overridden. This has to be implemented by the programmer. And the moment I say SAM, it is a functional interface. Okay, so that's the starting point. But now, as you can see the picture here. So one is extends thread, one is implements runnable. So I'm just explaining this point. Third point, I'll take it directly when I take you to web servers, web containers in advanced Java. So coming back to this, I can directly, as a programmer, I can implement, right? So here, see this. Sometimes when you see the code, things start reaching you faster. So here I can say public, or okay, I'll just give the title. First, I generally take the extend scenario. So here I can have implements scenario. Okay, but I just want to finish with the extends, finish off with the extends, and later all the time we'll be using implements more regularly than extends. But now if you see, there is because that is how I've written in my slide. So I'm just following that sequence. So here, if you see, this runnable interface has been already implemented by a Java class, built-in class. And which is that built-in class? Nothing but thread. So understand this. Is it a class or an interface? It is a class. Is it an abstract class or is it a concrete class? It is a concrete class. Okay. So java.lang thread is a concrete class. And the moment I say it is a concrete class, what is the next understanding I want from you? Has it implemented the run method or has it not? Yes or no? It must have implemented or it must not have implemented. It has to have implemented the run method, but Java doesn't know what business logic you want to add. So all it has done it is in an empty form. So has implemented run method in the blank manner. In short, what is it? What do I mean by blank manner? There is no business logic. BL is for business logic. It's a favorite question, popular question. What will happen? Okay, that I'll ask you in 2 minutes because I have yet to draw the hierarchy. So whether you use this okay, so this is one thing. So you can see later, you can confirm with the Java docs when we are together in the lab and all. So you can see the Java docs, and thread class is runnable, implements runnable. So what is one of the approaches is you as a programmer, you can extend from here. So anyone wants to tell me what will be the example? Now I'll start with this example. So I can say public class, let's say my thread, something, and which is the keyword for inheritance between classes. Everyone knows that extends from thread. Okay. So if I write only this much, now my popular question, not mine, in general popular question, what will happen? Compile time error, runtime error, or none of above? If I write this as a blank class, what will I have? Compile time error, runtime error, or none of above? Answer is no compile time error, no runtime error, but it is such a huge mistake. So what will happen is this will inherit the blank implementation logic. So what will happen? Your thread will be created. I'll show you how to start it. There's a start method. Your thread will start the execution, and because it has nothing to execute, the thread will immediately die. In short, what you have created is a useless thread, ineffective thread, no operation kind of a thread. So here, I hope the answer and question and answer was clear. So if you do only this much, definitely it will be do nothing kind of a thread. No compile time error, no runtime error. So tell me, in this approach or later in this approach, what is the common thing you will have to do? Anyone wants to answer? If I want to make a useful thread, I want to make use of it, you will have to override. Here we are saying override. Annotation, it's common. So which is the method? Sorry, I'll have to override. Everyone knows that. So it is your public void run. And this is where your business logic, execution logic of the thread of your user-defined thread, you will be encapsulating. Are you understanding? Of course, in addition to that, you can have utility methods, you can have constructor, all that is a detail. We'll detail it out soon. So this is one of the approaches of extending the thread where you can inherit the API and start with it. So now let me go a little bit deeper. I'm managing the state transitions. I'm trying to manage state transitions and the what is it? The concept. State transition and the API I meant, sorry. So here, if I don't write the constructor, everyone knows default constructor will be taken. And what is the first line in the subclass default constructor? First statement is super. So, and which is the super class? Thread. So open later. Looking at time, I'm not opening. Please open thread classes default constructor. So it will create an unnamed thread. So if you want to give the name to your own threads, there is an overloaded constructor. So just take a look at that overloaded constructor. It is nothing but a name-based constructor. So we can add. So how do I call it? Add overloaded constructor. Okay, to initialize or to set the name of the thread. So I can have, receiver thread, transmitter thread, or consumer, producer, worker, whatever we are doing, we can do that. So all those details will come when we start writing the code. But just keep this in your mind. Next one, is this the only approach by extending from thread? Yes or no? Answer is no. This is pending. So now, here, check this. When I say implement scenario, what will be the class definition? Okay, scratch that question. I have a better question to ask you. When I write the implements runnable, will your class be a thread? It's a yes, no question, Boolean question. I'll repeat the question. So don't be in a hurry. Take your time and answer. I said, in this case, if I write public class, my implementation class implements runnable, is it a thread or is it not a thread? All are wrong. All answers are this. It is not a thread. See, it is only a runnable. I'm saying that is why I draw the picture, inheritance picture. It is implementing runnable, so that makes it only runnable. But is it a thread? Is it extending from thread? Of course not. So how can you say? So this is the most important point and confusing to beginners. So don't feel too bad about it. So here, as a good programming practice, don't give the name of the class also as a my thread, your thread, and all that, because it is not a thread. So I can say public class. When you implement runnable, what is the only thing you are giving is the run method logic. That is, what is it your thread should do whenever it gets a chance? So typically all it represents is a runnable task. Okay, so you can, I mean, this is, you'll say, what is in the name? I can say it in anything. Of course you can, but that shows your understanding, that reflects your understanding. So I would like to call it as, maybe if you wanted, so this, my runnable task, like my thread I said here, this is the point to spend at least a minute thinking minute. So public class my runnable task. Am I going to say here extends from thread, or am I going to say here implements runnable? You know the answer. Implements runnable. Okay. Anyway, so here now same question, and it's easier this time. If I only write this much, what will I get? Compile time error, runtime error, or none of above? Of course, Java C error. Are you understanding? So whether you go by implement scenario or whether you go by extends, what is the common thing you will have to do? You will still have to supply the business logic by either implementing or overriding the run method. And which is the annotation we have? You know, it's the same annotation whether you implement or override. So here will be your run method, and this will be your business logic of the thread, business logic of execution. So are we clear about both the options? Is everyone clear that there are two ways I can create the thread? Oh, sorry. I mistake, a small mistake. So here, this is done. But here, if you observe, your class is already a thread, is a thread. So, you know, when I take you to the next point in that thread state transition diagram, I can just simply start the thread and go ahead. So once again, at the cost of boring you, I'll ask you, is my runnable task a thread or not a thread? This time at least you won't give me a wrong answer. Of course, it is not a thread. So here you will require, what is it you will need to do? You will have to create, you will have to take this runnable task and attach a thread to it. Okay, here this is not required. But here, of course, it is required. And when I say attach a thread and all, you might be thinking so complex. Absolutely not complex. In either of the cases, you are going to use thread class constructors. So which is that there are certain thread class constructors to be used in extends thread scenario. There are certain ones to be used in this implement scenario. So since I'm on this side, I'll write this. So the thread class constructor to be used under the implement scenario. Everything is well documented in the read methods, which I'll show you in a minute. So there is one called as thread runnable instance. I hope you don't require any further, what do you say, information. And here you have string name. There are multiple. Here there is a concept of a thread group and all, which I'll discuss over time. So answer this, I mean, understand this. A simple question. When I use, if I use the first constructor, the one with the runnable instance, what is runnable? Class or an interface? Interface. Can interfaces be instantiated? Absolutely not. So what is it you understand by runnable instance? Anyone? When I say runnable instance, I have taken a lot of practice for comparator instance and all. So I do expect the answer. Yes, instance of the class, of course a reference, but reference pointing to what? Instance of the class which implements runnable. I'll repeat the statement again. I already got the answer. So can I provide my runnable task instance there? 100% yes. You remember comparator instance, instance of the comparator interface, I mean, instance of the implementation class. So now go ahead. So which are the three different ways I can pass this? One way is if you have an extensive business logic, in threads, you can write hundreds of lines of code. And if you have an extensive business logic, my suggestion is write it as a separate class and you don't mix it up together. So first option is create a separate class which implements runnable and go ahead, pass that instance. Is there any shortcut to that? Of course, answer is yes. Which shortcut are we talking about? Can I create it as a anonymous inner class? Yes or no? Answer is yes. So what it will be? If you think in code, thread, new runnable, and open the anonymous inner class and close it. And which is the method you will have to override? Run method. Everyone understands it? I'm going to show you. We are going to write it all together in the lab. So, but I'm saying, if your body of the run method, if your run method logic is really tiny, maybe 1 or 2 lines, not more than that, is there a yes? Is there a further shortcut? Of course, yes. Lambda expression. So you can replace, this is a functional interface. And for last 2-3 days, we have been saying, anywhere you have a functional interface, can it be assigned to? Can it be substituted by a lambda expression? 100% yes. So depending on extensive logic which you have, if you have it, 100% suggestion is write a separate class. Otherwise, you can inline it. So forget that anonymous inner class. We hardly use it in modern Java. But what you can use is definitely lambda expression. And somewhere, if you're just calling the existing method, can be further replaced by a method reference. Okay, so now coming back to the point. So here, so if you use the first form of the constructor, what will it create? Named thread or unnamed thread? The first one I'm saying. Guess logically, smartly. Unnamed thread, those where you are supplying the name. Are you getting it? So who will assign the thread name? Java will assign the thread name. And what it will be? It will be like thread 0, thread 1, thread 2, and likewise. But if you want to give your own name, you can use the second constructor, which takes in again the runnable target, runnable instance, and the name of the thread. If you're still, confused and all, wait for 5-10 minutes more when we start actually writing the code. So this is the about implements. But the first example I take is by the extends thread. So which are the thread class constructors here to use in the extend scenario? Okay, so here answer the question, please. Do I have, I'm into this branch. My thread extends thread. My thread is a thread, etc. So in this case, think and answer. Do you need to pass this runnable instance? Of course not. The current class itself is a runnable. Are you understanding or lost? My thread is a runnable. Analogy. Array list, is a collection, is a iterable, etc. So similarly, can we say my thread is a runnable? Yes. So why do you have to supply separate runnable instance? You don't. So all you can have is, there are so many. There's a default constructor, which will create an anonymous. Anonymous means nameless thread. And if you want to supply the name of the thread, you have the name-based constructor. So all these things, I just write it on a whiteboard for understanding, for explanation and all that, but it is already written. So here okay, so let me say this properly. There are only 3 pages or 3 documents you have to refer if you want to understand Java multithreading inside out. One is thread state transition. One is threads API, which I'm showing you, all thread related API. And the third thing is there's something called as blocking triggers and unblocking triggers. That entirely covers all the things. So coming back to the point here, if you say thread API, whatever I talked to you just now is already written. So, it becomes impossible to remember, to capture all these things. That's why elaborate readme is there, and which one to use in which case and all that is mentioned. Okay. So getting back to our thread state transition. So here, what is it we said? Where is our thread? I mean, thread in the initial was initial status thread does not exist. So which are the two ways in which you can create a new thread? This is what I meant by extending a thread or implementing runnable. So now tell me, when you have finished this, where is this new thread existing? Okay, let me ask you a better question. Don't answer the earlier one. Is this when the thread enters the new thread, is it representing a separate flow of control yet? I said, when you create the thread using thread T1 equal to new thread, some thread class constructor, when you come to this stage, is your thread representing a parallel flow of control, separate flow of control? I got the answer is, correct answer is not yet. So then you will say, what is happening? Then what is happening is simply a thread class instance or that implementation class instance is simply created and sitting where? Where are the instances sitting? Of course, in the heap. So your thread class instance is simply sitting, or your runnable instance is simply sitting in the heap. But has it started competing with other threads? Is it representing the parallel flow of control or a separate flow of control? Not yet. So now then obviously the next step is start the thread. Okay, so have a look at it here. So this is your, how do you start it? All these Java API makes it such a beautiful abstraction. You don't have to go. I have given you in detail what happens when you call start internally so that you read. But all you have to call is thread class method, and that method is start. So after you call the start method, then your thread is taken out of your control. That is you are no longer controlling. And then there are further states to understand. So just read the API part first. Look at threads API. So constructors I have shown you. Read this. Only read the highlighted stuff, please. Okay. So whose method it is? It's a thread class method. Is it a static method or non-static method? Non-static method. So what has to be created first? First, you have to create the thread class instance and then call the method. Which are the two ways? Either implements or extends. Keep all these things in front of you. So now when you say t.start, T is just a thread type reference. What it will cause is the transition from new to runnable. I'll explain that illegal thread set in a minute. So let me again take you back. All answers are here. So this picture has to be kept right in front of you. So wait a second. So here the combination, see the word, the thread state which combines ready to run and running is called runnable. So all you can say is when you call the start method, the thread enters the runnable state. So let me differentiate between the two. So when you say start, you read my readme, there's another readme. So internally JVM calls something. So JVM calls the run method internally. It collects all the Java threads and gives it to the underlying operating system. So in simple English, all the transitions after this point, which transitions I'm talking about? This is swapping in. This is where your thread is getting a chance to actually execute the business logic. This is your swapping out. All these are mainly controlled by the operating system. So one thing at a time, start looking at this particular state. So what is the state? Nothing different I'm telling you. It is same as OS concept. It is OS concepts. So it enters the ready to run. What's the meaning of ready to run? Ready to run only means, is your thread ready for execution, or is it blocked on any conditions? Tell me, is it blocked or is it unblocked? Answer, it is completely unblocked. So what is the only thing it is awaiting is the CPU time. The only resource it is waiting for is the CPU time. Otherwise, it is not blocked on any condition. So here, can there be only one ready to run thread, or can there be multiple, single or multiple? Tell me. Answer is there in front of you. When you say pool, pool is what? Collection of equivalent resources, string pool. You remember? Literal string pool, which can store the references of literal strings and all that. So pool is what? You will see later, thread pool. This is your thread pool, instance pool, database connection pool, so many things you're going to see. So coming back to point, it is a pool and it internally uses priority based queue structure. So what it means is, forget the data structure part of it. What it means is, after this, your what? Scheduler, the operating system, that is scheduler, will check in, and whatever is the thread of the highest priority will be given the chance to what you say, to grab the CPU or to start the execution. So this is your ready to run to running transition, and anytime your thread enters the running state, which is the business logic. Where is the business logic you have written? We have written in the run method. So this is the time your supplied run method starts the execution. So I'll quickly recap what I said in last 2-3 minutes or 10 minutes, whatever. Here your thread is simply sitting on the heap. Thread class instance is simply created, but actual execution has not yet started. When you say start, it transitions to ready to run pool. In ready to run pool, it is awaiting. It is waiting for what? Is it waiting for some IO resources, or is it waiting for CPU processor as it? Processor or IO? I mean, is it blocked? Answer is only thing it is waiting for processor. So whenever it gets a chance, I mean, scheduler decides, it will transition it from ready to running. And since you can't really find out whether it is sitting here in the ready pool or is it running, this is combined called as, in combination called as runnable. So all you can say is your thread state is currently runnable. So now, again, I'm not sure whether you know, but I'm just tell you, what are the famous two scheduling algorithms, scheduling policies? I'm talking only about the superficial level. This is not an operating system session. So one is round robin, time slice based, and the other one is preemptive. You must be, I hope something you have heard of. So round robin, or the, what is it called? Time slice based. Suppose it is running. See, I'm saying Java is platform independent. So it has to work on all the platforms in respective of the scheduling policies. So what is it there in the time slice based round robin manner? The highest priority thread will be picked up. It will be given a chance. It will be given a particular time slice, and the moment time slice means some time, and the moment time slice is over, what it will do is the thread, don't look at yield. I have not yet come to yielding, so ignore yield. So this will be swapped out. And what will your scheduler do? It will pick up the next highest priority thread and give a chance for execution. Okay, that's your non-preemptive. That is your time slice based. But what happens in preemptive multi? So what it ensures is all the threads will be given a chance for execution. There is nothing like a starving. There won't be any starvation of threads. No threads will be, I mean, all the threads will be given the CPU attention. Next one. The next one is preemptive. So tell me, if the lower priority thread is running here, and if the higher priority thread becomes ready to run, what will happen? Who will preempt whom? The higher priority, lower priority thread will be swapped out, and the higher priority thread will be given the CPU time. So that is your preemptive type of multitasking. Okay. So this is, who is managing this? Programmer, Java programmer, JVM, or the underlying operating system? Of course, the native operating system, a component of native operating system. That is what I meant. So I'm saying In addition to all that, is there some request? Is there any way where I can request the underlying operating system that to give up the control to release the CPU and sit in a ready pool? Answer is yes, and that is your yield method. So balance between APIs and all this. So here I have not yet taken this. I'll take it in a minute. So just read this. It's an exam objective. We are not going to rely on yielding. Anyway, just read it and I'll explain. So what is it? How do we call this? You can see it is a static method. So in your run method, public void run, where you are writing the execution logic, if you want to enable cooperative multitasking, means what? Even the same priority or lesser priority threads also should be getting a chance to access the processor. If you are writing that kind of application, it is called as generous or cooperative multitasking, then if you say thread dot yield, who is requesting whom for what? The thread, the current owner of the CPU, the current thread is requesting the scheduler operating system to release the CPU, and it will be pushed to it will be swapped out to the ready pool so that some other thread, maybe of the same priority of a lower priority, will get a chance to access the processor. But I'm saying this treat it only as an exam objective. Why we don't rely on it? Because it is just a request. There is no guarantee that the underlying scheduler will do the swapping. So whenever we write any multi-threading code shortly, we don't use on something called as yielding. We will use the APIs which 100% work. uh, Not checking at all, Vipin, it is exactly what I said. It will try to swap out the currently written thread, request can be ignored exactly, and it will try to bring in some other thread of either the same priority or the lower priority. Okay, so that is the yielding part. But like I said, this is just an exam objective. Don't rely on it too much. Or rather, we will not use it in our actual multi-threading APIs, multi-threading code. So now I'll just take one more thing and then come to illegal thread state exception here. So this is where your thread is running. If your thread gets a CPU time, and in this running state, which business logic you are going to execute, the run method gets executed. So now here I'm coming to this part I will take last. So if your run method is over, when the thread returns from the run method, what does it mean? The execution, whatever is required by the thread is over. So which is the last state in the thread state transition diagram is dead. So whenever the run method either completes or throws some exceptions and it aborts, it's just a method. So it can abort, it can complete whatever. The run method returns or aborts, the thread becomes dead. And the important statement here is, by mistake, this is a programming mistake. If you try to restart a dead thread, I'll show you all this with examples in couple of minutes. If you try to call the start method on the dead thread, or if your thread is already started, it is already here, and again by mistake you call start, which is the famous exception. There is a writing mistake here. The name of the real exception is illegal thread state exception. So I have written it properly in my README. I never got it. I never edited this. So coming back to the point, which are the two triggers? Or I'll say it this way. If you get illegal thread set exception, what is the error you must have committed? You are trying to start already started thread. Okay, so dead thread either it could be or it is here and you are trying to restart it. So be careful about such mistakes. So this completes exactly one half. We started from does not exist. You looked at something, just at a superficial level, two different ways out of three. And when you say start, till this things are under your control, under your Java developers control. And after that, it is taken over by JVM partly and partly by the native operating system. But typically speaking, it never happens, practically speaking, I'm saying. In a practical scenarios, it hardly happens that your thread gets a chance, CPU slice, I mean, CPU time slice, and immediately it finishes the execution. What can happen more than often is thread, while its execution, can come across multiple blocking conditions. And I hope you remember the first statement. Why multitasking? Why multi-threading? So that even if a particular part or particular thread blocks, the other ready to run threads, other ready to run tasks should get a chance, and your CPU, your processor should never be kept idle. Okay, so that is what is going to give you the maximum throughput, maximum effectiveness to your application. So what are these blocking? Okay, so there are terms. One is called as blocking trigger. The other one is called as unblocking trigger. I'm telling you, this is the one of the important discussions. So when I say blocking trigger, understanding all of them is understanding multi-threading. So the simplest blocking trigger is, I hope you remember long back in exception handling, I had shown you thread.sleep. It's a static method. So tell me, a sleeping thread, should it be wasting the CPU cycles being here, or should it be swapped out to the block state? Obvious question, obvious answer. Of course. Why should it be wasting CPU cycles just by sleeping here? So immediately scheduler will swap it out, will place it in the block state. And is it dead? It's not dead. Poor thread is not dead. It is just sleeping for a while. So what happens? After the sleep duration is over, one of the unblocking trigger is sleep duration over. But understand the point. The moment the thread completes the sleep, whatever the pause, whatever the delay, can it resume the execution? Of course not. So the thread which is unblocked is placed into the ready to run pool, where it has to face the competition all over again. So it is just added into the ready to run pool, and whenever scheduler decides, as per its round robin policy or your preemptive task multitasking, whenever it gets chance, it can continue, it can resume the rest of the execution. But is sleep only the blocking trigger? Of course not. So you will see there is something called as join. You are waiting, one thread could be waiting for some other thread to complete execution. So that's joining. Till now, in the entire last, this is what, 16th day together. Yeah. So I have been talking about something called as thread safe APIs, thread unsafe APIs, string builder, string buffer, hash map, hash table, etc. So if you are using some thread unsafe objects, you have to apply the lock. And whenever you apply the lock, only one thread can access the resources. If other thread tries to access the same resource, of course, it will get blocked on the lock. I'm not going to handle it this way. Of course, we are going to write examples and all that. I'm just explaining. Recently, we were talking in IO. So if the thread is, suppose, right, I'll say something in code. Suppose you have done, so you have got some input stream and you have said in dot read, and the data is not available. What will happen to that thread? Will that thread continue to execute, or will it get blocked? Of course, it will get blocked on either read or blocked on write. So that is called as blocked on IO. And there is a beautiful concept of something called as ITC, inter-thread communication, which is a must between a producer and a consumer scenario, a handshaking between threads basically. So when I take you there, that's the advanced part of threads. So you'll know about, then you'll see the other trigger. So the point to understand today is, anytime a running thread, either there are two possibilities. Its time slice might get over, or it might get preempted. So then it goes back to ready to run pool, but it is not blocked on any condition. Whereas if it comes across some blocking trigger, you will see that it will spend time in the block state till the blocking condition is gone. till the unblocking trigger is introduced, and then the whole thread state life cycle or thread state transitions continues as always. I mean, continues in the same manner. Till what time? Till your business logic, till your execution logic of the thread is over. So this is your first look at thread state transitions. And like I'm saying, no, don't go to the protocol and all. It's a wait notification. Yeah, it is like a binary semaphore, or it could be Akshay counting semaphore also. So it is all abstracted by Java. But you are talking about something which is towards the end. So let us get started here. So the point I'm talking about is, let us write a first simple multi-threaded application just to confirm the asynchronous nature, parallel, concurrent nature, and then we'll get into the so many details, whatever you are asking. So here, wait a second, I was wanting to show you something. Yeah. So if you see, now you must have understood, you must have realized the blocking and unblocking conditions are so important. So this is what I'll be explaining whenever I come here. I mean, whenever we are talking about it, I'll tell you that this is the blocking trigger and these are the possible unblocking conditions. So you jump directly into wait notify, but it is this that I take towards the end of multi-threading. We have hardly begun. Okay, so all those things later. So, so what is the first thing? Let me see if I got a threads sequence here. Which classes hierarchy? The runnable and the thread class hierarchy, Surya? Are you asking me that, or are you asking me something else? Okay, so why don't you are you logged in with your computer? Please open, not just him. I'm not talking to him alone. Open, look for runnable interface. Look for its implementation class. So you will see runnable implemented by thread, and that we are going to extend further. Just look up the Java docs, please. So I'll explain. I mean, I will definitely revise it. It's an important thing, but in time. So here, okay, I'm just checking here. No, I won't. I don't want to do that. I mean, I was just looking whether I can reuse this. Let's not do that. Let's combine. Let's put it in your sequence itself. So here, enter threads. So we have looked at some little concepts regarding threads, but unless until you really write something, the things don't get clear. So the first requirement is use. This is the only time I'm going to use the extends thread scenario, because all other examples will do with implementing runnable. So use extends thread to test the concurrency of multiple threads, or to see the to test the concurrencies. That's fine. So now let's make you understand the API. So API and the concept both. So tell me, which are the two threads which are created by as Java threads? Which are the two threads which are already there in the system? Main thread and a garbage collector. So out of that, garbage collector has its own headache, has its own tasks, and it doesn't even get the chance unless until heap is under pressure. You know that. So we will use a main thread, is typically used as the parent thread. Okay. And this parent thread will be used to create child threads. And these child threads, so main thread, parent thread is what? System thread or user defined thread. It's a built-in thread, built-in as in JVM created thread. And child threads will be what? Programmer defined, I mean user defined threads or built-in. Of course, these are user defined. Are you getting it? So this is what we are starting. So I will just show you a little bit more API and we can do this. Give me a second. These earlier ones. I'll just open the threads API. Yeah. So now I'm going to use some of the methods. So I should explain them first. So what is the title? Title is methods of the thread class. These two are super easy. You yourself can understand. What is it doing? It is setting the name of the thread. The next one is getting the name of the thread. Okay, so setters and getters. Now read the Next part, I'll talk about it. Reread that. So whenever you are thinking in threads, the threads have a priority. So here, open the thread class. You can look for thread class, java.lang.thread. And as I was telling this one, Surya, it is runnable. Thread is a runnable. It tells you in quite in detail what is it this class represents. So you can read it definitely later. And here when I said thread class, see the point here. The priority scale is the one which I want to show you. So they are added as the thread class constants. So you can see there are three constants. It's a public static final constant, max priority, min priority, and a normal priority, the default priority. So this is 1, this is 10. This is a scale of 1 to 10. And the default priority with which even your main thread starts is 5. So here, tell me, which is the thread which will get a chance, which will get more chances to execute? The higher priority thread or a lower priority? Obvious question, higher priority. So you might be tempted. Okay, let me say this. So how do you set the priority of a user-defined thread? You don't have any constructor for that. You have a method set priority. So before you call that start method, see, after you call start method, threads are out of your control. So before calling the start method, if I want to set the priority within this range, it is possible. But another statement now I'm making. Are we going to use this priority factor in writing platform independent multi-threaded applications in Java? Answer is no. There is a reason behind. So see, whichever platform, whichever operating system you use, this Java scale remains the same because it is a Java class. But if you have a little bit of understanding of operating system on its own deals with its own priority scale. So if you are on a Windows operating system or a Mac or Ubuntu, I mean Linux, it might have different priority scale, priority range, I mean. So the same, you can't get the same output across all the platforms. So priority being a relative concept, relative to your operating system, generally we don't use it. So then why I spend so much time? Again, the answer is exam objective. So you should know, if at all you want to set the priority, how to do that. There is a method there. Next two are definitely very useful. So take a look at it. Both we will be using a lot. So what is it? First one is the current thread. Is it a static method or non-static? You can see it as a static method, so you can import static it or whatever. But when you say thread.currentThread, what is it going to return? It is going to return as the name, invoker thread reference. So let me ask you, if I put, I'm going to do that, all of that. I'm just preparing you before starting the code, the writing part. If you have when you have a main method, and if I put in a main method SOP, system.out.println, thread.mainThread, I'm so sorry, thread.currentThread. What is it is going to return? It is going to return the thread type of reference. But which will be that invoker thread? What will be the name of that invoker thread? Obvious question. Of course, it will be main. So that is what it is. It is what it's going to return you, the current thread or that invoker thread reference. And when we put it in our own run method, what it will return is that child thread or that user defined thread reference. And you can do the lot of debugging using that. Next one, last one, before I can take you to this. So here, before I can start writing the code, at least one code sample will write. Next one. So here it is a toString method. ToString has, thread class has overridden object class method. And what are the three details it returns. They are very important for your understanding, debugging, or whatever. First thing it will return you is the name of the thread. So it can be main, it can be your user-defined thread name, worker or producer or whatever. It also tells you what is the current priority of the thread, and all Java threads belong to a thread group automatically. Because see, your main thread is the parent thread, and from that you're going to create a child thread, children threads. So the thread group also, thread group is what? Just a collection of threads. So it will also tell you the name of the thread group. So the name of the thread group, unless and until you create your own thread groups, is also main. So main is going to be the name of the parent thread as well as the name of the thread group. And here we had done this long back. I don't know whether you remember. So here there is a static method sleep. So if you say thread.sleep, let's say 500 milliseconds, what is going to happen? This is the question best answered with your thread set transition diagram. So imagine means don't imagine, look at it here. Suppose your thread's execution logic run method is getting executed, and in run method, if I say thread.sleep 500 milliseconds, 500, tell me what will happen. You know the answer. Immediately the thread releases the operating system. I'm sorry, the test scheduler will release this. It will enter the block state. What is the reason behind blocking? Blocked on sleep. That is blocked due to sleep. And after 500 milliseconds are over, or there is a concept of an interrupt. So all these in the afternoon session I'll show you. So after, in either way, the sleep is over or sleep is interrupted, it will return to this, and then whenever it gets a chance, it will resume. So this is more than sufficient. Yes, this is more than sufficient to continue to write the first example. So before I jump into code, I'm just showing you from the picture what is it we are going to achieve, because your expectations should be set right. So here I'm starting with the parent thread. Okay, so this is your parent thread, which is the main thread. So is it a system thread or is it a user defined thread? Everyone knows it's a system thread, which is created by the JVM right at the beginning, main and garbage collector. And this is the one which is going to be used as the parent thread. And what will be the job of it? It will be used to create child threads. Okay. So this is what we are going to do. And currently, and okay, so just creating the children threads is not sufficient. Those will be thread class instances on the heap. So you will have to start them also. Start the same. Okay. So that will be the job of the main thread. And how will you confirm whether there is a concurrent execution and all that? So here, soon we will have the additional threads. These will be, I'm just drawing a couple of them. So here you will have the threads. I can call it as T1, T2, T3, whatever. So these will be your user-defined threads. And here, since it is the first example, which is the scenario we are going to use is using extends thread scenario. So here, in next whatever, I'm going to stretch it just by 10 minutes to be precise. Kind of precise. So here, user-defined threads, we will show with extends thread, and we'll see the parallel execution, and definitely we'll stop here. So let's start. So what should I start with? Should I start? Okay, sorry, scratch the question. This part will be written in what? A tester class. That is where the main, that is the starting point is. So this will be like a tester class. And initially, I'll not show you the inlining via lambda expression and all that. That we will do over time. So we will write a separate class which extends from thread. So here will be something like a my thread class, which I had already explained, which extends from thread. Okay. And all I'll do is the main thread is already started, created and started by JVM. So this is already running. I'll just start the concurrent execution, parallel execution of our user-defined threads. So how many threads will be running in our system? The 1 plus 3, as in 4. Garbage collector I'm not counting. And let us see whether you can see this concurrency. Is the objective clear? Is the requirement clear? Is the problem statement clear? Everyone is clear with that? Great. Now, so start telling me what should be my starting point. Should I start writing the tester first, or should I write my user-defined thread class, my thread class first? Tester or my thread? If you say Upinder, for example, tester, some of you said tester, tester is going to create the objects of this. So unless until a class is written, how can I start? So the answer is, see, tester, the integration point main, we write towards the end. So first let us let us focus on writing a thread class, and then we will be creating the instance and starting it on all from the main. Okay, so let's get started. I'll create definitely a new project. This much of a background, I can't really skip without, because if I could, skip all this and directly get you in code, but then you don't understand what is the state, what is happening and all that. So coming back to the point, day 16.3 is done. So let me create new one. We'll just check the concurrency and we'll stop immediately for lunch break. Here. So here, let's say I'm going to create packages to keep it all easy and clear for you. We're going to write a lot of multi-threading code today. So P1, I'm just thinking, okay, my thread is fine. You can say my thread, my runnable thread, or whatever I mean. What is the thing is exchange thread. Why there is no compiler error? Two reasons. It has the default constructor which calls the super classes default thread class constructor, and run method is already implemented in the blank method, blank manner. So here, what is compulsory? What is compulsory in this case? Which is the method I have to override? Otherwise, my thread will be an empty or do nothing thread. I have to override the run method. So here, looking at time, I'll just take the shortcut. You don't take that. So here, which is the method I want to this is, see, it is giving me all these methods. I can override anything. So all I choose to override is run method. You can see that. But it is completely useless to call super.run. It is do nothing method. So soon we will replace it by a simple delay loop kind of a thing. Just I want to see the concurrency. Okay. But now I'm saying, listen to the question carefully. If I don't add the constructor, it will give you the default subclass constructor, which will call the default superclass. So in that case, will I end up creating a named thread or an unnamed thread? It is an unnamed thread. You remember you don't have to remember. When we meet again in the lab session, I will make you go through the through the Java docs, and you will see that thread class constructor does not have a name. So what should I do? Provide or add parameterized constructor to invoke, to supply, to set the thread name. Okay. So here I'm adding a constructor. This can be done in 10 different ways. Simple way I'm suggesting. So tell me, which argument you want me to add here? What is the argument I need to have is name of the thread. And who will be calling this parameterized constructor? My main thread from the tester. This is the child thread. This is our own thread we are creating. So the creating and starting the thread and all those things will be the headache of your tester. So how do I go ahead? I want to call the parameterized constructor of the superclass. Everyone knows it. You can look at it. There is a thread class name-based constructor. So I'm simply calling super name. Answer the question. I can see lesser people here, but I'm just stretching it for next 2-3 minutes, not more than that. Coming back to this, when this line is executed, can you tell me what will be the state of the thread? I'll give you choices. Does not exist, newly created, runnable. I'm combining ready to run and running into runnable, Dead or blocked? Let me see your answer. Answer is newly created. Absolutely correct. So its instance is simply sitting on the heap. But is it runnable yet? Answer is no. So which is the method you need to call to make it runnable? I hope everyone remembers the answer start. So tell me, whose method is start? It's a thread class method. Can I say my thread is a thread? Yes. So can I inherit that public static, public void start method? Of course, yes. So what is it I'm using here is, I'm using the inherited API. Inherited API from what? Inherited API from your thread superclass, from the thread class. And now please tell me, after you say, so it will call this dot start, doesn't find it, it uses the inherited version. And now what will be the state of the thread? Choices are the same. Anyone wants to answer? After calling this, it enters a runnable state where it might be in the ready pool, or if it gets a chance immediately, if it gets a CPU time immediately, it may enter the running state. So I hope this part is clear. And all I'm going to write is, this is the first time I'm showing you how to write a multi-thread application. So there are certain thumb rules or design this for easy debugging. See, till now, till today, we were having a single thread of execution. But now when you have so many threads, easily you can feel lost, or you don't know which thread is doing what. So the suggestion is, identify which thread has started the execution. So I'm saying started execution. And anyone wants to tell me, I want to print the name of the thread. How? Quickly. So that is why I spent so much time in giving you the API. There is a superclass method get name, and my thread is a name. I'm sorry, my thread is a thread, so I can use the inherited API. When does the thread becomes dead? When the run method returns. So I'm saying execution over. And all the business logic, we will add whatever business logic. First one will not have a business logic. We'll have a business logic later. Here you're just getting a warm up. Just starting with threads. So another good suggestion is, whatever is the business logic, here wrap it in a centralized manner. Centralized exception handling manner. In short, nothing but a try and catch all. More on this in the lab session. And since here, what are we used to? We blindly write e.print stack trace. But instead of that, be smart. And here you supply which thread got which exception. So error in thread. And I just want to print the name. Because debugging becomes easy if you follow all this. And I want to print which error, which exception plus E. So this is the standard skeleton code snippet. So what will change when I take you from simple applications to the involved applications which have collection, IO, thread safety, inter-thread communications and all that? This part will be the same. It is the business logic which will become from simple to complex. So here, this is the first example. I'm just writing a simple for loop. That is how we typically start. I'm just having a loop, I less than 10, maybe 10 iterations I'm having, I plus plus. And I just want to find out from my console which thread and which is the execution counter. So which thread you know already. I want to print the name. This is just to make you aware of how to write this. And I'll say execution count is whatever. I. So now, if I write only this much, tell me, and suppose I create multiple threads, 4, 5, 10 threads. Here, what are the chances of seeing context switching? Context switching means the scheduler swaps out one thread and puts in another. I'll say very few. Why very few context switching chances? Because this is such a tiny. You'll say, why don't you make it 10 million? I can. But then who has time? We have lunch break already late. So the point is how to force, listen to the question, how to force the context switching. So yeah, not memory, this processor I'm saying. So here, just add the intermittent sleep. No, 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 interrupt is not. Yielding, we don't rely. The yielding is, Pallav, you are right. I can say yielding, but here you are going ahead of time. Wait, Akshay. So here, yielding is reliable mechanism or unreliable? It is unreliable. So which is the 100% guaranteeing API and simplest? Make the thread pause, suspend, and that is via thread.sleep. Wait and all will come much, much later. So here all I'm saying is thread.sleep. And here, let's say some 500 milliseconds. So now tell me, let me see whether your basics are at least, I mean, whatever I said for such a long time is clear or not. So when I say thread.sleep, suppose it was T1, thread 1, which was executing. What will happen to this? What will happen to the state of this thread? The current thread, current invoker thread will be, what will be the state? Blocked. What is the reason of blocking? Blocked on sleep. We're going to do this. I mean, everything I can't finish. That is why I'm asking you to come on a Sunday, please. So here, blocked on sleep, blocked on join, blocked on IO, blocked on lock. So many triggers you're going to see. This is the easiest. Okay. So now I'm 100% sure that we will see the context switching. And that is the easiest way to learn. Now, already so late. So here, let me write a tester in a minute and call it a lunch break. So all I have to do is now, I've done the major job. All I have to do is what? Create the threads. And I don't even have to start it because I've already called the start from the constructor. I just have to call the constructor. But before that, I'll do something. See the thing. Anyone wants to answer. When I run this, what will be the output? You remember what it returns? It returns you the invoker thread reference, and then it will call the toString. So what will it print? The name of the thread is main. The default priority with which it runs is 5, and name of the thread group is also main. So how many threads are running in our JVM currently? A single thread. So this is your thread class toString, main, name of the thread, priority, and the name of the thread group. But I don't want to see, I don't want to work in a single threaded system. We have dealt with it enough. So now create child threads and observe, I mean, conclude or whatever, and check something. Check or test concurrency. Okay, that's it. So let me create multiple. So let's say my thread. You can see T1. Anyway, this is just a variable name, reference type. New my thread. And what is the only thing I'm expecting from the user? User means scanner and all I'm not having. I'll just add 1, 2, 3, 4. The thread names. I'm going to ask, okay, some threads just to check your concurrency. Okay, so anyone, tell me, at this point in time, you can see where my cursor is. How many threads are competing with each other in the JVM? Answer is only one. Garbage collector is dormant, is passive, it's a daemon thread. But at this point in time, how many threads are competing with each other? Everyone understands it? No, no, somebody missed it. I need to start. You are wrong. See this, where the control will go, control click it. It goes to here. This is where it will create a new name thread. And this is where I'm starting it also from the constructor. So again, back to my question. How many threads are there? 1 plus 4. 1 plus 4 is that your one system thread and the 4 child threads. And just I'm doing some, it's a simulation. Dummy business logic for main. So here I'll just copy that. And you will immediately start understanding things, I hope. Of course, not in such a hurried manner, but maybe in the lab. So quickly tell me, why there is a compiler error on get name? Tell me, is this tester is a thread? No. And first of all, I don't have any instance associated with it. It is a static netlist. So is there any way I can find out the current invoker thread? Answer is right in front of you. So all I say is, see the method chaining, solve it from left to right. What will this return? Main thread reference, invoker thread reference, and then I'm saying get name. And obviously, why there is a compiler error? Unhandled check exception. So let's simply wrap it. Let me wrap the whole thing. I mean, I could have wrapped the only this in a catch-all block. All I need to catch is the interrupted exception actually. Print address main over. Okay. Am I done? We are, I guess, done. Okay, so here it is. And now when I run this and stop immediately after that, what do you expect to see? Do you expect to see the main thread getting all the 10 chances in a sequential consecutive manner, or do you expect to see the asynchronous nature? Asynchronous or synchronous? Simple question. Of course, async nature. That is what we are doing here basically. And wait for advanced topics and one annotation at the rate scheduler and all can do the trick. But that's a long time waiting. Anyway, people have already left the session. So anyway, let it stop and then you can check. So see this, guys, this is your, what is it called? Concurrent behavior. If you accept it, this is your main threads detail. For a change, it has started 1, 2, 3, 4 in a sequence. But after that, can you see the first thread got a chance to execute and then somewhere the fourth got a chance. So pick up any random sample, pick up this and tell me, concurrent behavior, parallel behavior, or a sequential behavior? Sequential or parallel, S or P? I hope you are saying parallel. So your fourth thread is getting a chance, second thread, third, and all that. And why main is getting lesser chances? I don't know whether you noticed, but here I'm adding a double the delay. I just wanted to ensure it is the last thread which gets over is the main. All those details later. And now observe something. Which was the sequence I had started it in 1, 2, 3, 4. But there is no guarantee. You are not controlling anything. So give up that idea of control and all that. Okay. So here it is all done by the underlying native scheduler. So if you run this 10 times, are you going to guarantee, are you expecting the same sequence or different sequence? Answer is any sequence. So see this 3, 2, 1, 4, and then your main thread completes the execution. And when all the threads are over, then the application terminates. So guys, I have stretched it beyond limit today. I mean, more than 15 minutes. So let us stop right here. And whenever you meet me in the labs, yeah, you can't predict exactly, Pillab. You're right. So please, of course, you will be, it's a hybrid combined session. So come with your laptops and all that, and we will discuss things. And we will, first, I will make sure that you are first 1 hour, you will have a proper serialization based assignment. And after that, remaining 2, 3, 4 hours, I can't say, whatever stretch maximum you can sit with me, bear me, we will have the threads topic. That will be all. See you after lunch break, 3 o'clock, 3 p.m. Yeah, see you around.